Hello there, and welcome again to the Sleepy Cosmic Lens. 4.6 billion years ago, our solar system was merely a giant cloud of gas and sprinkles of dust formed by ancient stars. But under the power of gravity, that cloud started collapsing, spinning ever faster and flattening into a disk. Solar systems are pretty much always flat disks because when things rotate in space, they tend to flatten out. A dense sphere of gas collected in the center. At its core, under intense heat and pressure, hydrogen began undergoing a form of transmutation, nuclear fusion, releasing an explosion of energy that continues to this day. The Sun was born. In this new solar system, small grains of dust began sticking together. Over 100 million years, a few grew massive enough that their own gravity crushed them into spheres. The planets actually were just leftovers from the Sun's formation, and slowly over time, they accumulated more and more material from the disk around the Sun. Our star's radiation blew away lighter gases like hydrogen and helium from the inner system. Ice was unable to form, and 4 rocky planets arose: Mercury, Venus, Earth, and Mars. We talk about the terrestrial planets. These are the inner worlds, the rocky bodies. While all started out with a similar evolutionary process, each reached a unique fate. If you learn more about these terrestrial planets, you will learn more about our own history, and fundamentally, space exploration is about learning about ourselves. The brightest planet in Earth's sky, Venus, is our immediate neighbor in the solar system at the closest possible distance of 38 million kilometers. The planet has shaped our understanding of our place amongst the universe. In the 1600s, Galileo Galilei observed Venus's phases, helping to confirm the Copernican notion that the planets orbited the Sun instead of the Earth. Humanity's comprehension of the solar system expanded over the centuries, but Venus's opaque cloud tops stirred speculation that habitable swamps or even oceans awaited below. Answers seemed in reach with the development of the first robotic visitor to another planet. But any craft venturing beyond Earth's protective bubble would endure the dangers of interplanetary space. A probe in space can be subjected to conditions which are far beyond anything we see on Earth. We're quite lucky. The Earth's atmosphere protects us from extreme temperatures or radiation from the Sun. The closer you get to the Sun, the more radiation that you have. When there's a solar flare, if the Sun does a bit of a hiccup, you can get really strong, powerful streams of charged particles that can actually knock out the spacecraft's electronics. Designing probes for the space environment requires careful consideration of radiation, heat, pressure, and also temperature changes, because it's very easy within the life of a mission to experience very high shifts in temperature. In the early 1960s, NASA began developing spacecraft to explore the solar system. The Mariner program consisted of 10 probes launched over a decade, destined for the terrestrial planets. After Mariner 1 failed just 5 minutes after launch, hopes turned to its successor as our first emissary to Venus, Mariner 2, a sophisticated unmanned spacecraft with orders to gather data on the planet Venus. The second Mariner blasted off from Cape Canaveral on August 27, 1960. However, piloting a craft toward the center of our solar system came with a special challenge. It's actually very difficult to get to the inner planets. A probe would gain so much kinetic energy, you need to be able to slow them down, or they just whiz right past. So a spacecraft leaving the Earth's surface relative to the Sun, it has very, very high velocity, and it's got to lose that velocity to be able to reach Venus. 4 months after leaving Earth, Mariner 2 passed Venus by, becoming our first interplanetary traveler. Mariner 2 was the first successful flyby of anywhere in our solar system, making that journey past Venus for the very first time, looking at that cloud-covered world and getting a sense of the gases in its atmosphere. Mariner 2 revealed a thick, crushing blanket almost entirely composed of smothering carbon dioxide. Venus is an inhospitable place. We wouldn't want to live there. Sulfuric acid rains down from near hurricane-speed winds, except it can't reach the surface because it's so hot. Despite being a similar size to Earth, we had not found a twin, but a worst-case scenario of a runaway greenhouse, a build-up of heat-trapping gases that spiraled out of control. Clouds trap heat, increasing levels of carbon dioxide from volcanoes. That heat in turn causes greater evaporation, more clouds, It's now insulated and boiling at this huge temperature. The accumulation of its thick atmosphere didn't just affect Venus's temperature and pressure. Mariner 2 confirmed that Venus spins on its axis opposite to the conventional direction of the other planets. But that may not always have been so. We think that in the first couple of billion years after its formation, Venus was rotating in a similar way to the other planets, and then over the last few billion years, Venus has been slowing down, almost stopped, and then actually rotating in the opposite direction. Venus's thicker atmosphere may be to blame. The Sun's gravitational influence could have pulled on it with enough force to cause the retrograde rotation. All we know is that there is something very strange in the history of Venus. It has a very strange atmosphere, and perhaps the two are connected. Hot on the trail of Mariner 2, the Soviets initiated the Venera program. The goal was not merely to pass Venus by, but to touch its surface. All the while during the Cold War, where the US was aiming for the moon, the USSR was also sending missions to Venus. It's the real red planet, you might argue. Early probes were crushed by the intense pressure before they even reached the planet's surface. As the first missions started to go and get closer data, it became clear that Venus had an extremely challenging environment. The next probe's parachute failed, but it reached the surface intact. Venera 7 made the first transmission from another planet's surface. The probe survived for 23 minutes before succumbing to heat and pressure. The Venera program, run by the USSR, was an incredibly successful mission. Actually, in terms of scientific exploration of our solar system, the probe measured surface temperatures of 475 darks, and scientists inferred an atmospheric pressure 91 times that of Earth's at sea level. 5 years later, in 1975, Venera 9 returned the first image from the surface of another planet, a single black and white photograph exposing a rather mundane rocky surface. It seemed to be an almost impossible task to battle land probes on a surface of a world like that, but the Russians achieved it and sent back the first images of that world. And once that mission had been successful, it was possible to design future missions to adapt to what we now knew those surface conditions were. The Soviets continued the Venera program into the 1980s, sending back ever more images and data. Those images, even today, are helping us to form our understanding of that planet, even though we're only just looking in a few small areas, rather than focus on one small area of Venus. NASA's next mission sought to map nearly all of its surface. On May 4, 1989, Magellan became the first deep space probe launched from a shuttle. The advantages of launching a probe such as Magellan from the shuttle, rather than from a conventional rocket, are that you have a bit more control over how it sets off. There are humans operating the shuttle, and they are able to safely check out the instrument before releasing it into space. That allows you to really efficiently send the probe off, without any difficult thrusting maneuvers or anything coming from the spacecraft itself. We started the activation procedures for the deploy. We went ahead and threw the switch, and sent Magellan on its way. 4 months after leaving Earth, Magellan began transmitting radar images of the Venusian terrain. The Magellan spacecraft could use radar to penetrate through that blanket of cloud to look at a surface that was totally alien. It was a world covered in volcanoes and areas of lava flows. Mapping of Venus quickly showed that it's also active. Venus is volcanically active, it's seismically active, processes are happening on the surface, land is changing, land is forming. Though some regions demonstrate geologic change and renewal, Venus's crust is hundreds of millions of years older than Earth's. Our neighbouring alien world cannot recycle its rock the same way our planet does through the movement of tectonic plates. Magellan revealed the possibility that within 2 billion years of its early history, Venus may once have been like Earth, with a liquid water ocean and habitable surface temperatures. We think that Venus originally had an atmosphere similar to Earth, but over time the water boiled off due to the sun's radiation, because Venus is closer to the sun than the Earth, so it receives more of the sun's light. As the sun ages, its luminosity grows, shining an ever more powerful light on the Earth. Combined with humanity's addition of greenhouse gases into the atmosphere, our planet may one day reach a similar fate. Potentially, our Earth could go the same way, so it really makes us think about how precious our environment is. There is a mystery with the origins of Venus that we want to understand, if only to potentially save ourselves in the future. It really is the evil twin of our Earth, and that was only revealed because of these robotic missions. The European Space Agency's Venus Express began orbiting the planet in One of the craft's more surprising discoveries was an uncharacteristically cold region, high in the planet's atmosphere, where carbon dioxide could freeze into snow, dipping to -175. Atmospheric layers like these entice astrobiologists. The atmosphere of Venus might be home to some kind of life. It's possible it wouldn't be anything like we think about here. As a world of so many extremes, a myriad of mysteries remain. Venus will retain its mysteries for a little longer, I suspect, if only because it hides them so well. Named for the Roman god of messengers, travelers and thieves, Mercury is the smallest planet in our solar system. At an average distance of 77 million kilometers from Earth, Mercury is the innermost world. Mercury is a tiny planet and very close to the Sun, and the Sun has a constant stream of very hot charged particles coming off it called the solar wind, and that actually stripped away Mercury's atmosphere a very long time ago, and it's actually creating a little helium atmosphere from the gases inside the rocks on the surface of the planet. Mercury is a world of extreme temperatures, over 400 cores during the day and near -200 cores at night. Understanding this tiny world is a crucial piece in the puzzle of the terrestrial planets. The world itself is remarkably dense. Like Earth, Mercury's interior has layers. However, Mercury's core contains far more of the planet's mass, 85% compared to Earth's 55%. If you think about what's underneath the ground of the Earth, or Venus, or Mars, if you strip away the atmosphere and the stuff on it, this is probably the core of what a planet looks like. It gives us a handle, a way to try to wind the clock back to those early days of our solar system, and that's why we're so fascinated by it. Launched on November 3rd, 1973, Mariner 10 was the last spacecraft of the program, but the first ever probe destined for Mercury. You've got a means of getting a tremendous amount of information that is beyond imagination at the present point in time. The energy costs to sink so deep into the gravitational well of the Sun, as Mercury resides, is more costly than to go the other way to the outer world. There were whole new areas in astrodynamics that had to be invented to be able to do this kind of thing. In order to reach Mercury, Mariner 10 was the first spacecraft to employ an interplanetary slingshot maneuver. Flying first by Venus, it used the planet's gravity to decrease the size of its arc around the Sun, bending its flight path toward its target. You have to do your rocket burns at exactly the right time. You have to alter your orbit in exactly the right amount. You have to do course correction, otherwise you can just miss. An error of only 1 mile at Venus, if not corrected, could result in a 1,000-mile error at Mercury. Approaching Mercury, Mariner 10 began transmitting photographs of a world pocked with massive craters, revealing more clues to the formation of our solar system. We think that these massive craters are evidence of early bombardment. So there was a period right after the solar system formed where there was a huge amount of massive asteroids and comets, which bombarded the planets. Mariner 10 was the first spacecraft to return to its target, revisiting Mercury 2 more times. To be able to fly past the planet not once, twice, 3 times, it actually helped us learn a lot more about this gravitational slingshot maneuver, which is essential to all of the missions that we used across the solar system. So Mariner 10 was the cornerstone of every single mission that we fly today. Across its 3 encounters, Mariner 10 returned over 2,700 pictures of Mercury, revealing nearly half the planet's surface. Since March 1975, the spacecraft has slept soundly, still in orbit around the Sun. The next mission to the innermost world would take decades of preparation. After a 7.9 billion kilometer journey lasting 6 years, Messenger entered Mercury's orbit. Messenger was the first chance to actually put a spacecraft into long-term orbit around the planet, Mercury, to truly map its surface. The probe had to circle the Sun 15 times before it reached the exact speed and position to be captured by Mercury's gravity. We got a whole world view of this planet, particularly the polar regions of Mercury, areas where there are craters that have been in shadow for billions of years. We're seeing all kinds of evidence for volcanism, the tectonic deformation of these plains, ghost craters which are pre-existing impact craters that were later covered over by lava. The striking images of the planet's surface helped confirm a theory that Mercury is actually shrinking. What we're talking about here is a phenomenon in the late stage of the evolution of planets. Planets were very hot in the early history of the solar system, and most of that heat still has a residue in the interior of the planets. As Mercury's interior cools, shedding the heat generated during its initial formation, the surface is pulled inward, causing the planet to shrink. The surface is scarred, and we see those cracks and fault lines as the ground beneath the crust shrinks. This is a bizarre world and one that is very much worthy of our attention. Messenger's mission came to a dramatic end in 2015. We'd like to end a mission in the most useful scientific way. When the Messenger spacecraft ran out of fuel, it was sent on a final experiment, and that experiment was to basically self-immolate on the surface of Mercury. While we could study Mercury from orbit, and we could make some educated guesses about the density of the surface, the best way to do that is to smash a spacecraft into it. Closing in on the Mercurian surface, Messenger was able to collect data on the magnetic anomalies in the crust and ice hiding in the shadowed craters near the planet's poles. Mercury will not be alone for long. Launched in 2018, the joint European-Japanese mission Bepi Colombo has been spiraling toward the innermost planet. The missions are designed to be as wide open in terms of their capabilities as possible, because we simply don't know the right questions to be asking of worlds that are as unknown as Mercury and Venus. That's what makes the exploration fun. Mars, a world half Earth size, hangs as a red speck in our night sky. The outermost terrestrial planet, Mars's orbit lies 78 million kilometers beyond Earth's. As telescope technology improved in the 19th century, observers began to record fascinating shapes on the Martian surface. The sketches of Italian astronomer Giovanni Schiaparelli hinted at extraterrestrial architects. In the late 1800s, Schiaparelli made observations of Mars and drew maps of its surface, and some of the features that he saw he labelled canali, meaning channels in Italian. This created great excitement that we might actually have neighbours. We might go to Mars and there would be other beings that we could talk to. In the 1960s, probes to the Red Planet sought to separate fact from science fiction. The fourth probe of the Mariner program became Mars's first visitor. Over a few hours, Mariner 4 captured 21 complete images and a partial 22nd, but each would take nearly 9 hours to transmit back to Earth. They had to wait so long for such a small amount of data. The figures cascade to the Earth, 240,000 bits of binary code representing 40,000 dots that will finally make up the first picture. They waited so long that they in fact started to colour in the pictures with pastels, because to actually process that data would take even longer, and they just couldn't waste time. The images did not reveal a world of extraterrestrial canals. When Mariner 4 gave us the flyby images of Mars, it revealed a desolate landscape. They saw dry rocks and craters and dust, and this is not at all what they expected, and I think that may have been disappointing to the community at the time. We took for granted that the variation we see on the Earth would be found elsewhere, not realizing how unique water, and in particular life, is. However, Mariner 4's pictures were snapped in a momentary flyby. A prolonged trip to Mars might reveal more. The penultimate Mariner mission would confirm whether or not Mars was truly uninhabitable. The Mariner 9 probe launched in May 1971. Mariner 9 became the first spacecraft to orbit another planet. The probe's instruments began to unveil the planet we know today. In nearly a year of operation, 2 television cameras transmitted more than 7,000 photographs to ensure that the entire Martian surface would be mapped. An extraordinary world of 2 halves. The northern hemisphere almost perfectly flat, southern hemisphere heavily cratered, pockmarked, highland regions, mountains, and sort of in between them is this anomaly, what we call the Tharsis Rise. It is an area where there was clearly huge amounts of volcanism in Mars's early history, an enormous rift valley almost 3,000 miles long, an astounding feature which no one expected on Mars. Mars has the highest mountain in the solar system, Olympus Mons, a giant volcano. It has dust storms, it has weather in its thin atmosphere, so it really is a very active world. We have fossilized riverbeds. There are mineral deposits that could only have formed in seas and lakes. We have features that reveal global oceans. Mars has revealed itself to be a world with a past. At least that was water-rich. Mariner 9 provided the first clues that water once flowed on Mars. Humanity's first close-up examination of Mars would be facilitated by two identical craft, the Viking landers. They were designed to learn as much as we could about the surface of Mars, given the technology that was available. Viking 1 and 2 would touch down on opposite sides of the globe. The first photo from the Viking mission was actually of the lander's foot. That's a really interesting first image to see, because it gives you scientific information as well about what the surface is like. In addition to collecting photographs and measurements of the surface, the Viking landers dedicated 3 experiments toward the search for life. The Viking spacecraft were looking to see whether there was any evidence, for example, of methanogenic microbes on Mars, microbes that would emit methane. Were there Martians? Was there some kind of life somewhere at the surface, or below the surface of that world? Scientists concluded that the makeup of Mars's soil, coupled with solar ultraviolet radiation, restricted the formation of living organisms. But Viking's findings didn't exclude the possibility that an ancient Mars once supported life. We don't know really where we are in the evolutionary cycle, and of course that's part of what we're trying to find out. With the Viking mission in the 70s, they were simple landers sitting down on 2 different spots. But if you really want to explore, you need that mobility. So we had a small little rover called Sojourner, which landed with the Pathfinder mission in 1997. It showed that we could operate a small automated vehicle on the surface of Mars, but again it couldn't go very far afield, so they decided to build 2 rovers with the lander, and the rover as one vehicle. The Mars exploration rovers were twin solar-powered robots, designed to hunt for evidence that ancient Mars once held water. They were equipped with an entire laboratory to measure the mineral content and other properties of samples that they were able to collect. It was just transformative, having that ability to be able to just have our automated human being going around the planet. Spirit landed in a crater which certainly showed signs of being once filled with water, but some time in the intervening history of Mars had been covered over by a layer of lava. So Spirit had to go on a much longer journey, travelling several kilometres to reach some mountains. And literally, the moment they got out of the lava field, they found what they coined the pot of gold, evidence that there was water in this spot billions of years ago. Spirit found rocks rich in iron and magnesium, which could only form when Mars was wet and warm. Spirit's twin, Opportunity, successfully landed on the other side of the planet. The Opportunity rover landed in a small crater, the ultimate hole-in-one, and right in front of that rover was direct evidence that there was sedimentary layered rock materials that can only form in the presence of long-standing water. The puzzle pieces have been falling into place. We have concluded that the rocks here were once soaked in liquid water. Spirit had to struggle for everything to achieve the goal of finding out the water history of Mars. For Opportunity, it was all laid out in front of her. Originally slated for a 90-day mission, Spirit lasted over 6 years. Opportunity kept going for another 9 after that, travelling a total of 45 kilometres, further than any off-world rover. Opportunity made us Martians. There's been a team of people that go to work operating the rover, and the surface of Mars has now become our neighbourhood. Mars can be both cruel and kind. They thought dust building up on the solar panels would eventually block the sunlight, and that would be the end of the mission. But those whirlwinds on Mars blew the dust away, kept the solar panels clean, allowed the rovers to drive further, to continue doing more science. However, in 2018, a planet-wide dust storm sealed Opportunity's fate. This dust storm was really sad. It actually was so huge it covered the entire planet. And then it lasted so long that Opportunity didn't have any power left. The rest of the instruments were working fine, but if you don't have power, you can't do much else. The last message from Opportunity was a message from the engineering instruments on board, and effectively it was, "My battery is getting low, and it's getting dark." And 15 years of operations on the surface of the Red Planet finally came to an end. Even without our rovers, humanity still had a close eye on the Red Planet. NASA designed the Reconnaissance Orbiter, or MRO, as a next-generation eye in the sky, capturing surface features as small as a meter. It carried a novel telecommunication system that other Martian missions could use for a navigational aid. Since its arrival in March 2006, the MRO has circled the planet more than 60,000 times and sent back more data than all Mars missions combined. Its powerful camera has mapped 99% of the surface in unprecedented detail, revealing a planet that is still active and changing. The reason we know a lot about Earth is our satellites. We can measure what happens as the planet as a whole, how it changes over time, and that's what Mars Reconnaissance Orbiter has been doing for Mars. It's been measuring changes over the planet as a whole. Having a vehicle orbiting around Mars like the Mars Reconnaissance Orbiter, with its high-resolution cameras, has revealed the planet as an entire world with a diverse geology, and in some ways it's actually got better maps of the planet Mars than we currently have for the Earth. The MRO identified places of interest to send future landers and rovers, continuing the hunt for Martian water. While there was very clear evidence of there being water once on the surface of Mars, we'd never really had a chance to get down there and dig it up and taste it with the instruments of a spacecraft. The Phoenix mission was landed near the northern polar regions of the Red Planet and had a digger on board. Just 6 centimeters below the surface, it came across this bright white material. The rovers have been investigating the history of past water on the planet Mars for almost 5 years now. Phoenix is the first mission to actually touch that Martian water. We tasted for the very first time the waters of Mars. Water is fundamental to human life. Knowing where the water on Mars is, how much there is, and how to access it is critically important for any potential future missions. While water is an essential ingredient to life as we know it, our robotic Martian spies have detected a chemical often created by life, methane. The probes that we've sent there have not yet found definitive evidence of life, but there have been some close calls. There have been some signals that potentially complex organic chemicals might be there. We have tantalizing hints of methane on Mars, and why that's important is, at least on Earth, methane is produced by living organisms. We call it a biosignature. It's entirely possible this could be geological in origin, but we may have found those first clues of life itself beyond the Earth. The hunt for life and other mysteries Mars still holds will continue with future missions. Where did the water go? Did it support life? Could it support life? Mars is a great example of all these big questions we have about the universe on our doorstep, and because it's on our doorstep, we can explore it more. And as we explore it more, like everything good in science, more questions arise. We continue to probe Mars's past, hoping to understand its transformation from a primordial watery world. Our star bears some of that responsibility. In order to comprehend the mechanics of the inner planets, we need to unlock the secrets that drive the solar system. We need to study the sun. The sun creates all the heat and light in the solar system that enables all life on Earth to exist. It's also created very extreme environments in the other terrestrial planets, prevented life on Mercury by stripping away its atmosphere. It prevented life on Venus by causing the evaporation of all the water and turning it into a runaway greenhouse. Our sun produces its own weather, matter and light streaming out, influencing every orbiting body to some degree. Every so often, intense flares rise above the surface, ejecting charged particles up to 3 million miles per second. Sometimes these ejections collide with the Earth. When you see those beautiful aurora, the northern lights or the southern lights, that is caused by solar storms, stuff leaving the sun, hitting our Earth's magnetic field. Now that's great, pretty pictures, but it also creates radio interference. It creates problems here on Earth. The surge creates a geomagnetic storm, which heats up portions of the atmosphere and applies drag to satellites. It interferes with navigational systems and induces harmful electric currents in power grids. So if we want to predict that solar weather, we need to understand how it originates, and we have to get up close and personal with it. Space-based missions have been trained on the sun for decades, but until recently, they've all kept their distance. Launched in 2018, the Parker Solar Probe will arrive within 6.2 million kilometers of the sun's photosphere, what we describe as the surface. The Parker Solar Probe is ambitious because it's going to get just so close to the sun, and as you can imagine, That's going to be quite a hot place to be, and also there's going to be a lot of radiation from the solar wind as well. Beyond the Earth's magnetic field, which directs most of the solar wind away from us, the Parker Solar Probe's instruments will have a shield of their own, 2 plates of carbon encasing a core of carbon foam. On one side, temperatures will reach up to 1,400 Dar, but behind the shield, the bulk of the spacecraft will rest at a comfortable 30. The ability of that spacecraft to survive the journey, for its instrumentation to work, and to deal with that input of thermal energy from the front side from the Sun is quite astonishing. The Sun's temperature is one of the peculiar puzzles we seek to solve. A big mystery. You go to the Sun, the surface is 6,000 Dar, move away, the temperature doesn't go down as you might expect. The temperature goes up, and it goes up dramatically, to 2 million Dar. How the Sun is actually doing that, we've got lots of theories, but the Parker Solar Probe will help us test those theories. It's really important for us to gain a greater understanding of the solar activity and to monitor it. It would be great if we could model it. The Sun is the engine of our solar system. The Parker Solar Probe is going to help us understand a lot more about that engine, how it actually works. We'll get to lift the hood of the vehicle for the first time. Humanity has long aspired to become a starfaring species, and the terrestrial planets may one day open a gateway to the universe. Mars is the closest within reach, but the challenges are many. While it takes a few days to get to the Moon, Mars is a completely different kettle of fish. A one-way trip to Mars would be roughly half a year, but a mission that brought humans back home would last 2 years. The biggest hurdle to start with is how do we get people to Mars, never mind getting them on the surface. Those technical challenges are certainly huge, that's for sure, but we have a pretty good history of overcoming that sort of thing. The biggest challenges are going to be the human challenges. Getting there emotionally healthy, physically healthy, that will be a major stepping stone. The communication delays would be considerable, the delays in getting medical help would be considerable, so those colonies would have to be very much self-sufficient. Crewed exploration will require well-planned infrastructure already in place. We need to be thinking about self-sustainable missions and the utilization of resources in situ, things like fuels, water from the planet, and using those to create the things that we need to survive. It turns out that Mars is not an easy place for humans to live on. If we were living on Mars, we'd actually have to live underground because in addition to the massive storms that exist and the cold temperatures, there is no ozone layer. The sun's rays come straight in, and that would cause cancers and other terrible problems in humans. It has all kinds of hazards to do with radiation, as well as the fact that its atmospheric pressure is only about 1% of the Earth's, its temperature is very low, it would not be an easy place for humans to make a home. Laying the first bootprints on Mars will require our brightest minds. There's some amazing innovation that needs to be done. By solving this for things like the lunar mission, there's all this translatable devices and technology and know-how that benefits us back on Earth. We always get benefits by doing this kind of new innovation and not being scared by these big challenges. Before we set foot beyond our Earth, we must answer a fundamental question: are these worlds meant for us? I think it's a fantastic philosophical discussion. Right now, we can colonize Mars at some point in the future. Whether we should or how do we do that appropriately? I believe that humanity has the duty to explore, and with that comes a duty of care to the places that we travel. For all we know, Mars might actually have living organisms on it. Until we could say with certainty that Mars was completely sterile, we need to be very careful how we treat Mars, and not just look at it as a place where humans can take over. We should step lightly. The moment we step foot on an alien world, we have forever changed it. Unlocking the secrets of the inner planets. Humankind learns more about our home. We look at Mars and we look at Venus, our neighbours. In a lot of ways, they are very similar to different times of the Earth, and that will give us clues onto our own history and our own destination. Though the past century of exploration has revealed much, we must continue pushing the boundaries. Explorers is who we are as human beings. We all do it from the moment we're born to the moment we die. Without exploration, we don't advance as a civilization. The question is not if we will venture to these worlds, but when. It's in our nature to explore, and to understand, and to investigate, and to be inspired by doing so. During the early formation of our solar system, 4 small rocky worlds assembled where the radiation of an infant sun was strong enough to push away light gases and destroy all ice. But with great enough distance, hydrogen, helium, and ices like water and methane were plentiful. In this region, 4 giants were born: Jupiter, Saturn, Uranus, and Neptune. Through their gravity in the early history of our solar system, these gas giants have vacuumed up all of the available gas. Humanity's curiosity extended to these distant worlds. We'd explored the inner worlds of the solar system. We'd gone to Mercury, we'd been to Venus, we'd been to Mars. But the big worlds of Jupiter, Saturn, Uranus, Neptune, they really beckoned to the scientific community. An expedition to the giants would require crossing a protoplanetary graveyard, a ring of asteroids, leftovers from the solar system's formation 160 million kilometers beyond Earth's orbit. We had to traverse the boundary in between Mars and Jupiter, the asteroid belt, and we only had some basic telescopic observations of some of these objects out there. And was it going to be a region of space that we could travel through? In 1972, NASA's Pioneer 10 became the first spacecraft to enter the asteroid belt. The asteroid belt, in our popular imaginings, is a rubble-strewn region of space, mountain-sized objects crashing together in slow motion. It's nothing like that. Scientists estimated a 1 in 10 chance that the spacecraft would suffer a serious collision. There's a lot of rock out there, but it is spread over an enormous ring or volume of space. Collisions do occur, but they are not as frequent as you might imagine. 7 months after entering, Pioneer emerged triumphant. Having a spacecraft like the Pioneers extend their reach out into the solar system was again another important stepping stone in our exploration of the universe. By year's end, the probe completed a flyby of Jupiter, using the planet's gravity to escape the solar system. Pioneer 10 remained our most distant spacecraft until A great deal that is most interesting in our solar system was beyond our reach until Pioneer 10 showed the way. In the 1960s, engineers at NASA's Jet Propulsion Laboratory noted an imminent alignment of the outer planets. A spacecraft would be able to harness the gravity of each and swing from one to the next, using minimal amounts of fuel. It was recognized that you could do a grand tour, the idea of visiting more than one planet. But if NASA missed their chance, the alignment wouldn't reoccur for almost 2 centuries. Voyager was an epoch-making moment in the annals of spaceflight. Twin probes were crafted, Voyager 1 and Voyager 2. Together, they would provide unprecedented access to the outer reaches of our solar system. It was going to be the first time that we had pictures of such incredible detail of those distant bodies. Let's measure these things in great detail, but moreover, they're going to keep going. Let's build them for the long term. Let's see how long they can last. 1970s technology would have to endure the harsh environment of space for decades. The Voyager spacecraft, by today's standards, are quite basic vehicles. They had old television cameras on board, not too different from what might have been used in a television studio. Their recording systems were 8-track tape. Nevertheless, the equipment was capable of capturing essential details of the mission targets. Each Voyager probe also carried greetings from humanity. The legendary scientist, astronomer, and communicator Carl Sagan decided to send a cultural object along with the scientific missions on the 2 Voyagers, and this was the famous Golden Records. Nominally, it's a message for any alien species who happen to find them, but actually, it's a message to us as humans that we have something a little bit special on our planet that we would like to send out into space. If extraterrestrial life could decipher the instructions to play it, the record would reveal 115 images, 90 minutes of music, and greetings in 55 different languages. Voyager 2 was launched first on August 20th, 1970. Voyager 1 followed 2 weeks later. In less than 2 years, each arrived at the first proverbial stop on their grand voyage. The largest of all the gas giants, Jupiter contains 2.5 times the mass of our solar system's other planets combined. Jupiter formed from all these little globules of matter, basically colliding together in the very early days of the solar system formation. The infant world hungrily swallowed nearby asteroids and comets, bulking its mass even further. Eventually, when it cooled down, it was able to accumulate gases. So now it has a sort of a solid core, and then this huge amount of gas around it. Jupiter is truly the king of the planets. It's the dominant force in our solar system, except for the Sun. Pioneer 10 had captured our first close-up images of Jupiter, but the Voyagers would expose even more of the planet's secrets. We knew there was something going on, and when Voyager got close, it saw a very complex place. It's all weather patterns, more similar to here on Earth. One of the key targets, Jupiter's Great Red Spot. It's like a tropical cyclone, but huge. It was first observed almost 400 years ago. Just to simply exist so long, it's fascinating and still not completely well understood. In the 19th century, the Great Red Spot stretched 3 Earths across, but when the Voyagers visited, it had decreased too. The scale of Jupiter in particular, I think, is one of the more striking reminders of just how small we are when you look at features and realize the entire Earth can fit within with space to spare. It really is the land of the giants. While Jupiter's massive cyclone had been known for centuries, Voyager 1 revealed a completely new feature: rings, like Saturn, so faint that no one had spotted them earlier. The rings were likely formed by Jupiter's moons shedding dust, which settled into their parent's orbit. Future discoveries would reveal rings around every gas giant in our solar system. Saturn turned from being the solitary jewel to actually being just one of a whole family of ringed planets in our solar system. The Voyagers also investigated some of Jupiter's natural satellites. The moons of Jupiter, pivotal in human history because of Galileo's discovery of the 4 large moons of Jupiter. That kind of turned our view of the solar system on its head. Galileo's 1610 revelation helped disprove the geocentric model of the universe. Earth, the other planets and their satellites all moved in orbit around the Sun. The innermost Galilean moon, Io, is a hellish world, home to as many as 400 volcanoes. The volcanoes are spewing sulfur dioxide, and they're actually producing a ton of sulfur dioxide per second. The Voyagers captured a surface covered in lava and salt, in part caused by the moon's close elliptical orbit around such a massive body. Normally a moon wouldn't have such an active core, but it's actually being caused to have an active core by Jupiter itself. The uneven gravitational tug of Jupiter drives rocky tides. Io's surface bulges in and out by as much as 100 meters each cycle, and the frictional forces keep its interior warm and subsurface rock liquid. It is the most volcanically active body in the solar system because of the internal pressures and temperature that generates. But it's the smallest of the Galilean moons, Europa, which holds the most interest. Scientists believe Europa has a subsurface ocean with more water than exists on Earth. Europa has liquid oceans under its heavy ice shell. We can see the effects of currents in that ocean, convective currents flowing to the surface and breaking up the ice. It's a circulating ocean, and where there is water, there is the opportunity for life. We're talking now about the potential of Europa being a living world. We've got liquid water, we've got a strong energy source, and organic chemistry. On Earth, those same ingredients in less than 1 billion years gave rise to life. Closer images of Jupiter and its moons would have to wait until the end of the 20th century. The Galileo spacecraft deployed from Shuttle Atlantis in 1989, but its journey to Jupiter would span 6 years. En route, Galileo witnessed an extraterrestrial collision. In 1994, the spacecraft watched as the comet Shoemaker-Levy 9 was torn apart by Jupiter's immense gravity. Sometimes there's a lot of luck in space exploration. Celestial mechanics came together to give us one of the most spectacular events in our solar system. Many thought that Jupiter's clouds would simply swallow the pieces up. However, as each fragment crashed into the atmosphere, they released more energy than Earth's entire nuclear arsenal. Galileo was able to capture the distinct holes, the distinct impact craters, and that the biggest one was thousands and thousands of kilometers wide. The collision of Shoemaker-Levy 9 demonstrated how Jupiter's gravitational presence affects our own world. With Jupiter, we have this gravitational bully that has influenced our own history as much as that of all the other planets. Jupiter, because of its gravity, pulls these things into it. It is very likely that it has shielded us from asteroid and comet impacts, which may help understand why life formed here. Under the Galileo mission, 2 explorers ventured to Jupiter. A small probe accompanied the main spacecraft, bound for a brief but crucial encounter with the planet's atmosphere. Each arrived in December 1995, but while Galileo entered orbit, its probe dropped beneath Jupiter's cloud tops. The Galileo probe was actually able to plunge down through that atmosphere and see if there was water. The probe quickly hurtled to a final measured depth of 180 kilometers. Did it rain from the clouds of Jupiter? What were the temperatures? What were the pressures like? Was there lightning in that atmosphere? And along the way it discovered all of those things, proving the theories that we had about this dynamic world for the very first time. After loss of signal, the probe was vaporized. In 2003, following its 35th orbit, a dying Galileo was steered into Jupiter's atmosphere, meeting the same fate. The craft had not been sterilized prior to launch. This act of destruction would ensure no life, had it survived the journey, could contaminate Jupiter's moons. For the next 13 years, we could only study Jupiter from afar. In 2016, the solar-powered Juno spacecraft arrived and settled into a polar orbit. The purpose of the Juno spacecraft was not to show us the clouds of Jupiter once more, but to actually understand more about what's going on inside the planet. How do gas giant planets like Jupiter actually form in the first place? We don't know how big worlds like that actually get built. On each of its highly elliptical orbits, Juno passed Jupiter with only 8,000 kilometers to spare. This is akin to skimming around a basketball just 1 centimeter from the surface, but which we're doing at tens of thousands of kilometers per hour. Juno allowed us to understand what height beneath the clouds down to the core itself. We've got a wibbly-wobbly core in the interior of Jupiter, generating this enormous magnetic field, a magnetic field that is some 20,000 times greater than the Earth's. Juno was actually built with significant shielding just to prevent its electronics being fried by these close approaches. Inside Jupiter, it ceases to be a gas giant. The hydrogen becomes compressed into liquid, and it takes on metallic properties. Juno has helped us understand that structure in incredible detail. As we enter the 1980s, both Voyagers approach their next target, the second largest planet in our system, named after the Roman god of agriculture, the ringed world Saturn. Saturn has been observed in the night sky since antiquity, and its rings revealed not long after the first telescopes were crafted. When Galileo turned his telescope towards Saturn, he was really confused. No one in humanity knew that a planet could have rings around it. The best you could come up with trying to describe Saturn was that it looked like a pea. In 1659, Dutch astronomer Christiaan Huygens employed a more powerful telescope of his own design and deduced that Galileo's ears were actually a system of rings. Each Voyager spacecraft arrived at Saturn months apart. The Voyagers revealed a huge amount about Saturn. They discovered rings that had not been detected from the Earth. Rings 200,000 kilometers across, but only maybe 10 meters thick, on average overall. They were able to resolve the rings into their component parts. Little chunks of rock and ice, grains up to boulders as large as mountains, racing around the planet at 880,000 kilometers per hour, with its own strange magnetic field suspending dust particles above and below the rings. In the last day, we've learned a great deal about Saturn, surrounding rings and moons, from the dramatic pictures that have been brought back by the Voyager 2 spacecraft. With Voyager's new data on the rings, their puzzling origins became a little clearer. The rings of Saturn have been a mystery for many years in terms of how they came to be there. Had they formed with the planet itself, or did they materialize later? Saturn's immense gravity destroying a smaller wayward body. Perhaps it was a relatively recent event in which an ice moon got too close to the planet to stay intact and became broken up into rings. Christiaan Huygens also discovered Saturn's largest moon, Titan, in 1655. Later that century, an Italian-French astronomer by the name of John Dominique Cassini discovered 4 more. In 1997, NASA, ESA, and the Italian Space Agency launched their joint exploratory mission named after both men, Cassini-Huygens. In many ways, the Cassini-Huygens mission grew out of the Voyager missions because what we saw in the vicinity of Saturn was utterly tantalizing. The mission consisted of 2 separate spacecraft, the Cassini probe, which is a NASA project, and the Huygens probe, which actually came from Europe. These two teams from different sides of the Atlantic who could achieve so much more, I think, than either project would have done alone. For me, a highlight in the exploration of the outer solar system has to be the Cassini-Huygens probes. We've learnt so much about not only Saturn, the beautiful ringed planet, its atmosphere, its rings, but also its many, many moons, which are really fascinating. An extraordinary mission, 13 years of absolutely marvellous discovery. Some of the things that were found were so surprising they'd never been thought of when the spacecraft was being planned. Cassini-Huygens arrived at Saturn after a 7-year journey, the first mission to orbit the planet. Cassini provided unprecedented detail of Saturn's rings by flying through them. Mission Control had to precisely navigate the craft through the debris. Tensions were high on every pass. What will it encounter as it passes through that ring? What effects will there be on the electronics of the system? Are there particles or small objects with which the spacecraft will collide and be destroyed? That requires some very, very clever use of orbital mechanics. We saw evidence for essentially water falling out of the rings, something like 40 tons per second. The rings themselves are actually raining onto the planet's surface. Cassini was able to observe the first hurricane-like structure on Saturn, the Great White Spot, and watch a hexagonal atmospheric structure at Saturn's North Pole change from blue to gold. The hexagonal feature that's at the North Pole of Saturn is due to a massive hurricane, and it's about 50 times more massive than any hurricanes we get on Earth. Again, there are weather systems like on Earth that there are on these gas giants, something we never would have thought of. On July 19, 2013, the Cassini spacecraft imaged Saturn and its entire ring system during an eclipse of the Sun. One of the most spectacular images that returned was actually from the far side of the planet, looking back towards Saturn with the Sun lighting it up from behind. Spanning over 650,000 kilometers, the picture detailed Saturn's second outermost ring, composed of fine icy particles. The photograph also features a pinprick of light, the Earth, 1.44 billion kilometers away. NASA knew that the Earth was going to be in that shot, and decided to say, everybody on that day, at that moment, go outside and look towards the skies, because your photons will be emanating from the surface of the Earth and received by the Cassini spacecraft. During its mission, Cassini snapped images of many Saturnian moons, but one held the spacecraft's focus, Enceladus, Saturn's 6th largest moon. Its distinctive southern stripes sit atop a saltwater ocean buried kilometers below its icy surface. Close inspection by the Cassini spacecraft showed cracks in that ice and showed water geysers spraying out from a subsurface ocean. These eruptions fling material into space, and it means that you don't have to land on this moon to access this ocean. You just wait for a geyser to erupt. And Cassini was flown through those geysers, was able to taste those waters, and found that the water was warmer than we expected it to be, and it was full of both simple and complex organic chemistry. It suggested that there could be thermal vents at the bottom of an ocean where life could thrive. If I had to bet on a best candidate for life in our solar system, I think I would pick Enceladus. If we can actually go to Enceladus in the future and send drones under the water and see what's down there, I think that will be an absolute watershed for our understanding of whether life could potentially exist in our solar system. Maybe life really is common out there, or the conditions for life are common out there, and if this little cold place around Saturn has it, it's probably common. Decades before Cassini, Voyager 1's brief encounter with Saturn's largest moon, Titan, whetted our appetite. Without a question, the images that were returned this morning revealed a world unlike any of the others that we've seen. It was tantalizing. It's all these things that we hadn't known before, but left so many questions unanswered that we just had to go back. The secrets of Titan were buried beneath its thick, hazy atmosphere. It's opaque for the same reasons that we get this haze of smog in some of the more populated areas of the world. Titan's atmosphere is rich in hydrocarbons, mostly ethane and methane, and the effect of the sun's radiation on those hydrocarbons is to turn it into a very hazy atmosphere. After deploying from Cassini on December 25, 2004, Huygens began a 22-day journey toward its target. Upon arrival, Huygens descended for 2.5 hours. The European Space Agency sent a landing mission to Titan as part of the Cassini mission. It successfully soft-landed on the surface and sent back a whole bunch of data, the first craft to land on an outer solar system body. Huygens continued to transmit data for 72 minutes until its batteries were drained, and it revealed to us a world that has ice mountains and sand dunes and river-like features, not from liquid water flying from the surface, but from organic molecules of ethane and methane raining from its clouds, flowing across a water-ice surface and flowing into vast lakes. It was almost primordial. It was kind of like a snapshot of what we thought Earth was like 3 billion years ago, when life was just starting to come into play. And if life formed on Earth in very similar conditions, maybe it's forming or has formed on Titan. This is not life as we know it, but it's conceivable that something could be there. The chemistry is complex enough that that life may form. Could we recognize it if it did, is perhaps another question. After 20 years in space and 294 orbits of Saturn, Cassini was running out of fuel. The mission embarked on yet another risky first, a journey between Saturn's atmosphere and its rings. The choice was to send Cassini through Saturn's rings, through a very small gap actually, and to do this multiple times to learn more about what was there. Diving through Saturn's rings 22 times, Cassini sought to determine their age. In 2019, astronomers revealed the answer, somewhere between 10 million and 100 million years old, a fraction of the age of the 4.52 billion-year-old planet they encircle. And then, eventually, the final swan song was to send it into Saturn itself for a very scientific ending, where it was transmitting important data right until the last second. Signal from the spacecraft is gone, and within the next 45 seconds, so will be the spacecraft. 4 decades before Cassini's demise, Voyager 1's mission to Titan ensured a lonely outward path, a journey that sent it straight out of the solar system. Voyager 2 carried the responsibility of visiting the remaining planets, the ice giants Uranus and Neptune. Sir William Herschel first observed Uranus on March 13, 1781, though he did not initially identify it as a new planet. After all, it was the first that had not been known to the ancients. Just over 2 centuries later, Voyager 2 approached within 82,000 kilometers of Uranus's cloud tops. Uranus is an oddity. The Voyager's eyes were able to show us really a lot of interesting features of very high jet streams racing through its polar regions and equatorial zones, and to show a little bit more detail than we can get from here on Earth. Voyager 2 studied Uranus's unique atmosphere, manipulated by the planet's strange orientation. Uranus lies on its side with a tilt approaching 90. It's thought that an Earth-sized object may have collided with Uranus long ago, pushing the planet over. Its atmosphere reaches the lowest temperatures of any planet in our solar system, plunging as low as -224. The ice giants are so far away from the Sun that they're receiving a really tiny amount of the Sun's light, between 1/100th to 1,000th of the Sun's light. Uranus's distinct colouring comes from the presence of methane in its atmosphere, which exists in greater concentrations than in its larger siblings. But like all the giants, Uranus has its own system of rings. The brightest of the Uranian rings had been discovered a decade prior aboard the Kuiper Airborne Observatory, an airliner fitted with an infrared telescope. Voyager observations brought the total to 11 points. Voyager 2 also provided up-close images of the moon Miranda, one of the strangest bodies yet observed in the solar system. When that first of the series of Miranda images came in, just where it was supposed to, it was that sense of, oh my god, we did it. It looks like a world that has been smashed up, torn apart, and then put together again really, really poorly. One half of it is deep corrugated furrows on its side, and the other half of it is an average-looking pock-marked moon that you would see orbit around another planet, and there they are together. They're completely different, but they're in the one body. Cliffs that are over 20 kilometers high, and the gravity of Miranda is so low that you could stand at the top of that 20-kilometer high cliff, look straight down, jump off the edge of that cliff, take 20 minutes to reach the bottom. You're better to land on your feet and walk away. In August 1989, Voyager 2 approached the final target of its grand voyage, Neptune, which was first revealed not with a telescope, but with mathematics. The planet Neptune was discovered by its gravitational pull on the planet Uranus, so before we even saw it from the light that it emits, we inferred that it would probably exist because the orbit of the other planets were kind of being pulled out of line, so to speak. With Voyager 2 at so great a distance would require a new technical achievement. Probes like the Voyagers are very quiet. The further you go, the bigger and bigger we need to make our receiver dishes to pick that up. In 1986, NASA established its Deep Space Network, 3 communication complexes around the world that improved our ability to capture the weak radio signals from Neptune. Our job is to send commands to spacecraft so they know where to go, what to do, and what information to collect. Each complex of the Deep Space Network has a 120 tegrad field of view. To achieve full coverage, NASA built the first station in California's Mojave Desert, the second station in Madrid, and a third near Canberra in Australia. Once a mission travels more than 30,000 kilometers from Earth, it is always in view of at least one of the stations. I describe it as being air traffic control for the solar system or the postal service for the universe. In 1987, the 3 main telescopes were expanded to better hear Voyager 2's Neptune encounter when it arrived 2 years later. Voyager revealed at least 4 rings of ice and rock. It also discovered the Great Dark Spot on the planet's southern hemisphere, a raging transient hurricane the size of the Earth. The winds on Neptune can reach speeds of over 2,000 kilometers an hour, the fastest in the solar system. En route, engineers altered Voyager 2's trajectory so it could study the largest of Neptune's moons, Triton, a world with a thin atmosphere with geysers spraying out dark sooty material, not water ice as we'd experienced on some of the inner moons of the other giant planets, but dark material that thin atmosphere and winds were carrying across the surface, creating dark streaks on the surface of the moon. Days later, it snapped a final photo. Neither Uranus nor Neptune have been visited since. The ice giants Uranus, Neptune were all but points of light to astronomers until the flyby mission of Voyager 2. We started to realize Uranus and Neptune are very different than Jupiter and very different than Saturn. We kind of had this view, pre these missions, that the 4 gas giants were all the same. We saw worlds that had some of the coldest temperatures ever recorded, with some of the fastest winds ever moving, where the energy for such dynamic systems is still a bit uncertain. We've been sending deep space probes out for decades now, but there are these 2 planets that we know only from the visit of Voyager 2. We really know very little about these planets, and it's very much overdue, I think, that we send back another probe and have another look. We might have a reason to go back, but we have so many places to explore beyond Earth in our solar system. Where do we go? There's just too much to do. Beyond our outermost planet lies a mysterious realm of small rocky worlds that the Voyagers would merely pass through, but they were not forgotten. 4.5 billion kilometers beyond our Earth lies a realm of icy bodies, the remnants of our solar system's formation, the Kuiper Belt. It's a huge region at the edge of our solar system where the comets live, so it's a very, very mysterious region. Despite its massive size, the Kuiper Belt wasn't discovered until 1992. Within it lies a world once called a planet, Pluto. Discovered by 24-year-old Clyde Tombaugh in 1930, Pluto was reclassified as a dwarf planet in 2006, following the discovery of several other objects in the Kuiper Belt that were similar in size. However, that has not detracted from our desire to unlock its secrets. The New Horizons probe was developed to expand Voyager's grand tour of our solar system. The New Horizons spacecraft was able to go where the Voyagers couldn't go. They couldn't encounter that final traditional world of our solar system, Pluto. The probe embarked from Cape Canaveral on January 19, 2006. There were so many unknowns about Pluto, how it was formed, what it would look like. At a distance of nearly 5 billion kilometers, it would take over 4 hours to send and receive radio signals from the probe. The download speed from New Horizons was only 1 kilobit per second, 50 times slower than the dial-up modems of the 1990s. It took 15 months for all of the information it gathered to return to Earth. Everybody was waking up in the morning, ready to download all the latest images that had come in and been processed and were all being put up online. It's just amazing what this meant to all the people that worked on it, but it also meant a lot to people around the world. Until New Horizons, scientists weren't even sure of the dwarf planet's actual size. They were able to conclude that Pluto is 2,376 kilometers in diameter, the largest of the catalogued dwarf planets. But it was the features on its surface that were truly astounding. A world with nitrogen ice glaciers flowing across its surface into valleys underneath mountains that were 3 kilometers high, made from water ice covered in a nitrogen snow. The textures and the patterns make it look a bit like an artwork in places, and surprised us by revealing an extraordinary heart-shaped region, a very smooth landscape, a new surface. And by new, I mean within perhaps 1 million years, certainly not the ancient cratered surface that everybody expected to see. As New Horizons departed Pluto, it revealed a naturally blue sky created by nitrogen gas, just like on Earth. The sun shining behind Pluto, lighting up that blue atmosphere and the blackness of deep space that we're travelling out into, leaving behind the worlds of our solar system to head into the interstellar void. Observations of the outer solar system continue to raise as many questions as answers. Indeed, a number of objects beyond Pluto follow unusual orbits that could hint at an unseen gravitational force. Another planet, currently dubbed Planet 9. If we look at the other objects in the very outer solar system, some of the asteroids, the rocks that are floating out there, they seem to be pulled a little bit off target. These orbits all seem to line up pretty well in one direction, and that tends not to happen by chance. There could possibly be a very massive planet out there that we haven't yet discovered, Planet 9. For it to be there, and for it to be having the effect that it is, it has to be pretty big, somewhere between Earth and Neptune, what we call a super-Earth, which is interesting because super-Earths are very common around planets around other stars. So one of the most common types of planets in all the other star systems just happens to be the one we're missing. Mathematical modelling and computer simulations hint at Planet 9's existence, but it has yet to be observed directly. Now, a Neptune-sized object would be quite big, and you might expect that we would see that pretty easily, except that this could be 20 times as far away as Neptune is. The light that we see from the planets is reflected from the Sun, and if there is a 9th planet, it would be so far away from the Sun that the light would be incredibly faint. The problem is that the most likely direction that we think this thing might be in, this hypothetical Planet 9, is actually slap bang in the middle of the Milky Way, the most dense part of the sky as far as how many stars there are. How do you separate what could be a planet, a dim reflecting object in the night sky, from the many other background stars? Well, it moves relative to these background stars, which to our telescopes essentially appear fixed. As it would take Planet 9 between 10,000 and 20,000 years to orbit the Sun, it could remain a distant mystery for years to come. We're looking for a needle in a haystack, but the needle looks like hay. That's why Planet 9 hasn't been found yet, if it is there. The Voyagers are now the furthest objects forged by humanity, and as such, they've given us the most distant photograph of our home. On February 14, 1990, Voyager 1 took a final image, turning its cameras back to the inner solar system and taking a panorama, a family portrait if you will, of the entire solar system. And within one of the beams of sunlight, a tiny pale blue dot, the Earth, seen from the perspective of deep space. I think it made everyone stop and wonder a little bit, just about how large the universe is, and our place in it. In some ways, Voyagers 1 and 2 have both already entered interstellar space. There are a few ways to define the edge of the solar system. One is to say, where does the influence of the Sun end, and that would be called the heliosphere. Both Voyagers have passed that last remnant of our own solar system, and continue into our larger galaxy. They have fuel that will probably mean that they can send signals back until maybe the mid-2030s. It's quite amazing that something launched back in the 70s could still be talking to us so far into the future. The Voyager probes carry with them a history of humanity as spacefaring explorers and the promise of future discoveries. It's the serendipitous discoveries as you go further and further into unknown territory which we look back on and say, didn't expect to see that. The depths of space called, and humanity answered. The Voyager spacecraft fundamentally changed our idea of what the outer solar system was like, and showed us new worlds that beckoned to be explored. And we have left off. Our missions to the outer solar system have provided nearly half a century of milestones. You really felt part of it. Every decade of your life you saw something new about our own solar system. It was completely inspirational. Each robotic surveyor has opened up the possibilities of future missions. If we can actually go to Enceladus in the future, I think that will be an absolute watershed for our understanding of whether life could potentially exist in our solar system. These distant travelers are a monument to human exploration. It makes all of the solar system and beyond a human place, because that's how far we've gone. Stories of close encounters with alien life are part of our culture. Every year in the US, there are thousands of reported sightings of UFOs, unidentified flying objects, and some people even claim to have been abducted by aliens. I'm a perfectly normal individual that's had rather extraordinary odd experiences my entire lifetime. Natural phenomena or even military activities can explain most of the UFO incidents, but some still keep people guessing. There's no way that it was balloons or an aircraft or helicopters or flares. People actually saw a 1 to 2 mile wide craft. Flying saucers have invaded our planet. Skeptics argue that such sightings and close encounters are merely figments of our imagination, perhaps inspired by science fiction movies and popular culture. You have a dream about an alien in the middle of the night. What is your alien going to look like? Your alien's going to look like my alien, the alien we both saw on television. Although even respected scientists admit that real aliens could have the capability to travel vast distances across the cosmos to visit Earth, there is no law of physics preventing a civilization, perhaps 1 million years more advanced than ours, from reaching the planet Earth. Some believe that there is overwhelming evidence that aliens have visited us, possibly on many occasions throughout history, leaving artifacts and messages ranging from crop circles to the pyramids. I saw some strange objects and strange lights. I saw some things I couldn't explain. They were definitely under intelligent control. For those of you that are skeptical, I would ask that you look at all the incidents. There are some very serious things out there. Some incidents really need some investigation. In 1995, Dr. Lynn Kite saw lights she could not explain near her home in the mountains, just north of Phoenix, Arizona. She had her camera with her. I really concentrated on that top orb that was starting to disappear. It didn't budge. It just slowly dimmed, as if once it disappeared it was still there. And I noticed an eerie silence, as if time had stopped. It was just extraordinary and very strange. 2 years later, on March 13, 1997, Kite was also among the thousands of witnesses who shared a remarkable experience. Thousands of people statewide were looking up purposely to the sky on a clear, beautiful night to catch a glimpse of the Hale-Bopp comet when this 1 to 2 mile wide triangle craft traversed the entire state. I mean, it really went through the most populated corridor of Arizona, totally silent. This was a massive parade throughout the state. Some people find it hard to dismiss the Phoenix Lights case because there were so many eyewitnesses. After a brief investigation, the military revealed that the lights were created by flares released from a squadron of aircraft flying in a V formation. Despite this explanation, some people maintain that the lights were otherworldly. Pyrotechnic expert Paul Mann has worked with flares for over 23 years. He believes that staging this event would be incredibly challenging. I think you would find it very difficult to mistake a flare for what people would regard as a UFO. Although he won't be launching the flares from a fighter jet, Paul believes that he can explain the difference between flares and the Phoenix Lights. Here are our flares, which will go to about 300 feet high. Give you a constant burn, but you'll see there's a slight flicker in it. Anybody would be able to spot that's a flare rather than a craft. So we've got a shimmering red light there, lots of smoke, you can see the smoke trail. The pinpoint of light will give it away as a flare, and it falls to the ground, it doesn't hover for hours. So for anybody who saw the Phoenix Lights, if it was a pyrotechnic that could last for so long, that was quite an achievement, and to get it to hold in the sky was something else altogether. I know what I saw, and thousands of other people know what they saw, and it definitely was not flares. The characteristics are quite different from these orbs. There's no smoke trails, These are balls, these are orbs, and are in rock-solid formations. The data speaks for itself. Some people believe that flares are an improbable explanation for the lights over Phoenix. Dr. Michael Shermer, publisher of Skeptic magazine, thinks the incident highlights the difficulty of judging the truth about UFOs. People are poor eyewitnesses, all of us, judging the size, motion, and speed of objects in the sky, particularly at night or at dusk. It's very difficult to do. Shermer has been writing about the unexplained for over 10 years. He questions not only the quality of the evidence, but also the reliability of human testimonies. When somebody says, "Oh, it was 200 meters wide in the sky, how do you know? Was it next to something that you knew the size of already, and then you can judge it's twice as big as that?" No, people just make wild-ass guesses. These wild guesses include mistaking military aircraft, weather balloons, flares, and even the planet Venus as alien craft. Yet such sightings lead many people to believe in the existence of UFOs, despite logical explanations from scientists and the US government. Ironically, official denials of UFO landings may actually encourage a popular belief in their existence because of a fascination with conspiracy theories and a fear of government cover-ups, particularly in the infamous case of Roswell. Roswell, this is the mecca of ufology. Initially, the story given that it was a weather balloon was a lie. It was a lie because it was a national security secret. It was a national security secret until 1995, when the government said that Roswell wasn't actually a high-altitude weather balloon, but a high-altitude surveillance balloon to monitor Soviet nuclear tests. This revelation only serves to convince the UFO community that the government is still covering up whatever did happen at Roswell. So the ufology people said, "Oh, you see, we've been saying that they lie." "Yeah, right, but they're saying what it actually is." "Yeah, but that's a lie." "No, that makes perfect sense for a Cold War atmosphere in 1947. The mystery surrounding Roswell has been fueled by misinformation and the shifting official explanation that keeps the story alive. Yet sometimes, even the military themselves spot the unusual. In 1980, personnel at an Air Force base on the east coast of England saw a strange light in a nearby forest. Deputy Base Commander Colonel Charles Holt was on duty when he received a strange message from one of his staff. When the on-duty police lieutenant came in and insisted on seeing myself and the base commander and talking to us privately, he was white as a sheet. The lieutenant reported that a strange unidentified flying object had been seen descending into nearby Rendlesham Forest. Colonel Holt and a disaster preparedness officer visited the supposed landing site. They recorded their mission as evidence. "What we do, we make a sweep. Got the Geiger on, let's make a sweep around the whole area." All the birds got quiet. All the animals in the forest were just silent. We approached a site where they said this alleged craft had landed. There were 3 indentations in the ground, about 1.5 to 2 inches deep, about 8 to 10 inches across. They were about 6, 7, maybe 8 feet apart, in a nice triangular shape. Being cautious, Colonel Holt and his disaster preparedness officer took radiation readings with their Geiger counter. The levels were 4 times higher than normal. We got a high reading, about 2 to 3, maybe 4. Then something moved in the trees. A bright red light with a black center that was moving through the trees. There's no doubt about it. There's some type of strange flashing red light here. It appeared to be shedding something like molten metal, almost like steel coming out of a crucible. As we stood there and all watching it, it silently exploded and broke into multiple white objects that just disappeared. Many journalists and researchers claim that what Colonel Holt and others actually saw while in Rendlesham Forest was in fact the lighthouse at nearby Orford Ness. But Colonel Holt remains convinced that what he saw wasn't of this world. "I know what we saw, but I don't know what it was, and my own personal suspicions are that there may have been a craft that was damaged, injured, or it may have been a reconnaissance vehicle of some type, taking a look at all the activity in the area." In January 1981, Colonel Holt contacted the British Ministry of Defence, but never received an official response. He is convinced that his close encounter was genuine, and that governments cover up this and other UFO cases. Dr. Michael Shermer is not so sure. Problem with government cover-ups like that is people can't keep their mouth shut. If aliens were really here and the government was covering up, Surely some lower echelon person would say, "I've got the story of a lifetime." Even if governments were trying to cover up UFO incidents, people haven't stopped questioning the official explanations. Either aliens exist or they don't. Either thought is frightening. For any UFO to get here, it would have to travel across space from another part of the universe light years away. Where might they come from, and just how would they get here? Has Earth ever had a close encounter with an alien civilization? There have been many supposed sightings of UFOs, but no definitive evidence of a visit. But whether or not aliens have dropped into our own backyard, many scientists do believe that they could exist. I would be shocked if we were alone. It would be an incredible waste of space considering how many galaxies there are. There should be lots of planets like ours with life on them. The universe is about 14 billion years old and expanding at a phenomenal rate. It holds billions and billions of stars, far more stars than there are grains of sand on all the beaches on Earth. And some of these stars have planets orbiting them. There are plenty of places from which ET could originate. Physicist Lawrence Krauss believes that the most likely place for ET to call home would be on a planet similar to our own. Life seems to form ubiquitously, relatively easily, in conditions like this, so we would expect one simple way to find life would be to look for planets like Earth. The problem is that any such planet is going to be a long, long way from Earth. Outer space distances are so vast, they are measured in light years rather than miles. 1 light year is a distance of nearly 6 trillion miles. That's the distance travelled in 1 year by a beam of light moving slightly in excess of 186,000 miles per second. Light from our own sun reaches Earth in about 8 minutes and takes another 10.5 years to travel to the nearest known planet outside of our solar system. Any alien planning to visit us from this planet faces a round trip of over 120 trillion miles. The only way to shorten the duration of such a journey may be to go faster than the fastest thing we know in the universe, light itself. In 1905, Einstein laid out special relativity, and in that theory, you cannot go faster than the speed of light. There's a cop on the block in some sense that says you can't break the light barrier. Einstein's theory of special relativity suggests that there is a cosmic speed limit preventing anything, and any alien going faster than the speed of light. However, in 1916, Einstein created an even more powerful theory, the general theory of relativity. It opens up the possibility that, instead of beating the laws of physics, the answer might be to get around them. Theoretical physicist Michio Kaku believes that this holds the key to breaking the light speed barrier. Space-time is a fabric that could be stretched and compressed and perhaps even ripped. That might give you the possibility to break the light barrier. Einstein's theory proposes that matter causes space-time to curve. Imagine a heavy ball on a rubber sheet. The ball's presence causes the sheet to distort into a hollow. If a smaller ball is then dropped onto the sheet, it will spiral toward the heavier ball. Einstein theorized that space, like the rubber sheet, is warped as objects travel through it. And if space can be warped, then there may be a novel way to travel from one side of the galaxy to the other. If you have a sheet of paper, a straight line is the shortest distance between 2 points. However, there's a loophole. If you are to fold the sheet of paper, then you realize the shortest distance between 2 points is actually a wormhole. Some scientists suggest that wormholes are space-time tubes which act as shortcuts, connecting distant regions of space. Theoretically, an alien using wormholes could travel between 2 parts of our galaxy faster than a beam of light could travel through normal space and time. It's a shortcut first described more than 150 years ago by a mathematician in Oxford, England. That man was the author known as Lewis Carroll. Alice's Looking Glass connects the countryside of Oxford to a fantastic world called Wonderland. And if you were to put your hand through the looking glass, your hand would leave Oxford and go to the other side of forever. That is a wormhole, what we physicists call a multiply connected space. Wormholes may be the ideal transportation network, but manipulating the laws of physics could bring catastrophic consequences. You don't know how stable they are. It may be quite radioactive. There may be quantum corrections and radiation as you enter the wormhole, or perhaps it will close up even before you can enter. It may be possible to artificially create a wormhole, but it would take enormous energy and advances in technology way beyond our imagination to rip through the fabric of space and time. But maybe there's an alien civilization so advanced that they can build these supergalactic highways with ease. Intelligent aliens may also have found another trick to navigate around the universe. Perhaps they can actually move space itself. As far as we know, space can do whatever the heck it wants. It can expand in response to the presence of matter and energy. If we could somehow harness that, then in principle you might be able to develop something you might call a warp drive. The alien craft would collapse the space in front of it and simultaneously expand the space behind it. In that way, the ship would transfer from one part of the galaxy to another without actually moving an inch. It may sound like the stuff of science fiction, but for some advanced aliens, it could be science fact. I can show you with this balloon. I have a little replica I've drawn of the USS Enterprise from Star Trek, and just so you know the local surroundings, I have the Sun here, I have the Moon, Saturn, and what I want to show you is that the Enterprise could travel away from this star system and towards this star without ever moving with respect to its local surroundings. How can I do that? Well, if I squeeze the balloon at this end, then I expand this region of the balloon. The distance between the starship and these stars has increased, but the starship hasn't moved at all with respect to its local surroundings. And so what I've done is I've had space do the work. Nobody knows how a warp drive might be powered, and Krauss believes that its use would be fraught with danger. It may not be dangerous for the participants in the spacecraft, but it'd be pretty dangerous for everyone else, because when you contract space in front of you, you literally crush everything between you and that star. When you expand space behind you, you put incredible tension in everything around you. You'd have to have an interstellar highway where you cleared out everything in between, because otherwise you destroy basically everything around you. Our own technology is nowhere near sidestepping the laws of physics, but an alien civilization that has evolved a million years ahead of us might already have found a way. Earthbound physicists who are looking for life take this idea very seriously. They have devised a system to categorize alien civilizations according to how advanced they may be. When we physicists look in outer space, we don't look for little green men, we look for Type 1, Type 2 and Type 3 civilizations. A Type 1 alien civilization would be so advanced it could harness all forms of energy on its planet, including oceans, volcanoes and even the weather. They would soon exhaust the power of a planet and use the energy of their local star. At this stage, they would be categorized as a Type 2 civilization. Eventually, they become galactic, they begin to colonize entire star systems, they begin to have fantastic energies, allowing them to manipulate stars and black holes. That is Type 3, perhaps a 100,000 to a million years more advanced than our technology. But where would our own civilization be on this scale? We don't even rate on this scale. We get our energy from dead plants, oil and coal. That's how primitive we are. Our official rating is Type 0. We cannot travel across the vastness of interstellar space. However, a Type 3 civilization would have developed the technology needed to control space and time in order to travel freely throughout the universe. You cannot rule out the possibility that an extraterrestrial civilization, perhaps a million years more advanced than ours, have the capability of reaching the planet Earth. But any alien civilization developing ways of travelling across the galaxy to planet Earth still faces potential disaster. If they reach us at all, then the oxygen in our atmosphere, the very thing that keeps us alive, may prove to be deadly poison for our alien visitors. If an alien civilization has successfully learned how to control time and space and cross the interstellar void to visit Earth, they will face a serious danger: our atmosphere. It protects us from solar radiation, but it's a dangerous barrier for any approaching spacecraft. As an object approaches Earth from space, it heats up due to friction with molecules in our atmosphere. The heat burns up most objects, such as asteroids, before they reach the ground. NASA spacecraft use this friction to slow down as they re-enter the atmosphere. Heat-resistant tiles protect them from the intense heat. Without them, the ship would burn up. But some physicists believe that a technologically advanced civilization would solve the problem long before they reach our atmosphere. I would suspect that any intelligent creature with an advanced form of space travel would simply slow down even before it reaches the planet Earth. Having navigated our atmosphere and landed safely on our planet, the aliens face their next big hurdle. It's unlikely they could just step out of their craft. Earth's atmosphere would probably not match exactly the atmosphere on the home planet of a visiting alien. In fact, unless the aliens were adapted to oxygen, they would find the gas extremely poisonous. Aliens come to Earth wouldn't expect them to just walk out of their spacecraft and breathe the air and start eating apples and oranges. Here in the Mojave Desert in Nevada, NASA's Space Science Division studies how Earth's basic organisms live in extreme environments. From this, they hope to ascertain how different species might survive potentially hazardous conditions. Leading the research is Dr. Chris McKay. We take for granted that life needs oxygen, and we all need it. Plants and animals need oxygen, but we have developed very special machinery and enzymes for detoxifying oxygen. Oxygen is intrinsically poisonous, but would evolution have happened in the same way on the home planet of an alien visitor? Would they have evolved to cope with oxygen? In an extreme case, the fundamental chemistry might be completely different with different gases. Dr. McKay studies samples that contain over 10 million bacteria. They reveal that some species here exist using totally different principles to the vast majority of life on Earth. If we look at the bacteria, we get a glimpse of how strange chemistry really can be, how these organisms can be really so alien. The strength of our sun poses another problem for visiting aliens. The energy from its rays supports life on Earth, but it can be dangerous. Too much sun can blind humans, burn us, or even cause cancer. For a creature from another planet, our sun's rays could be deadly. You can imagine life forms from another world coming here and finding the UV light here to be stunningly bright and require extensive sun shields and sunglasses and other ways to protect themselves. And then there is Earth's invisible hazard for aliens, gravity. A visitor from another planet might find Earth's gravity a challenge. Humans have grown up with it in bodies designed for 1G. If we subject our own bodies to extreme gravity, the consequences can be disastrous. Fighter pilots making extreme turns can experience forces as high as 9Gs. That means that a 160 lb pilot feels like he weighs over 1,500 lbs. Anything above 9Gs, the pressure becomes too great and the pilot will black out. Aliens from a planet with less gravity would probably experience a similar effect. Say the Martians came to Earth. Well, on Mars, the gravity is a third of Earth's. The gravity would be higher for them, so even if they were fit by Martian standards, they might find this high gravity a drag. But it's not hard to postulate them have the technology to allow them to operate in higher gravity. A far less predictable danger facing a visiting alien is germs. Just as in H.G. Wells's War of the Worlds, simple bacteria might be deadly to visiting aliens. The bacteria on one planet could have serious consequences for organisms on another planet. The Martians come, they invade Earth, they kill off the armies of Earth with no problem. But then the bacteria on Earth infect the Martians and kill them. In the end, Earth wins the War of the Worlds, but not because of the prowess of human technology, but because of the biochemical diversity of the bacteria. History has shown that there is good reason for visitors from another world to be cautious, and for us to be cautious about them. When the Spanish invaded the Americas, they brought a far deadlier weapon than their guns and swords. They brought smallpox, the flu, and other illnesses. When those barriers were reduced and life spread between the New World and the Old World, there was a lot of death and destruction as a result of that. We might contaminate visiting aliens, or they might contaminate us. This fear of infection from new species of bacteria also troubled NASA during the moon exploration of the 1960s. They placed the first astronauts returning from the moon in quarantine in case they carried deadly space germs. McKay hopes that an alien civilization exploring the universe would also be careful not to contaminate planets with their bugs. One would imagine that an alien civilization with the technology to move between worlds would have the sense to realize the same problem and have strict biological barriers and controls. They wouldn't just land and go out for a picnic and spread out their stuff on another world. It's clear that the occupants of an alien spacecraft traveling to Earth would face a catalogue of dangers. First, they would have to survive the destructive forces within a wormhole. then avoid burning up in the Earth's atmosphere, and finally protect themselves from poisonous oxygen or deadly germs. Perhaps alien visitors would decide not to take the risk themselves. What if they send explorers who never age and who never die from deadly diseases? The most efficient way is with robots. These are self-replicating nanobots. Nanobots are miniature robots, minute and lightweight enough to be potentially invaluable in space travel. One of the major factors in traveling fast through space is weight. The smaller you are, the faster you can go. In fact, subatomic particles can travel at near the speed of light, so tiny nanobots may be the best way of exploring the universe. Scientists believe that it might be possible to create microscopic nanobots able to clone themselves. These would land on moons and planets and self-replicate, allowing an alien civilization to explore vast tracts of the galaxy without ever leaving their home planet. Eventually, you would have a sphere of perhaps trillions of robots expanding near the speed of light, landing on moons, each robot creating other robots. That's the most scientifically reasonable way to explore the galaxy. That's how nature does it. That's how viruses work. Humans are already exploring the cosmos using robots. NASA's Voyager probes are heading deep into space, sending back data as they go, and robotic rovers have explored the surface of other planets in our solar system. But because of their size, it appears that nanobots could be the most logical way to explore the universe. But so far there is no evidence that alien nanobots have ever visited Earth. And even if they have, will we be able to detect them? The vast majority of people who claim to have had close encounters, in fact, describe not miniature robots but living alien creatures, often none too friendly and prone to abducting, probing and experimenting upon their victims. An advanced alien civilization might be able to manipulate physics and cross time and space to visit Earth, but some scientists question why on earth would they want to. They suggest that beings capable of travelling through space and time would be millions of years more advanced than humans and would find life on Earth of little interest. And even if they do want to make contact, they might not be friendly, based upon the human race's own history of confrontation. Michael Shermer, publisher of Skeptic magazine, has his own theory. If you go by what happens here on Earth, we would never want to come into contact with ET. We would be eaten or enslaved or killed, because that's what happens here, so that's not good. Even so, some people claim to have already had a close encounter with extraterrestrials. Some even claim to have been abducted by them. The alien abduction experience is a fascinating one. These stories have all the earmarks of a very human kind of experience. It's a type of night terror. It's a bad dream. Because there is no evidence, outlandish accounts of alien visitation are greeted with disbelief. So most claimants are keen to conceal their identity. One woman from New York, who we have named Molly, claims to have experienced repeated visitations throughout her life. Probably the most strangest and disturbing memory that I have is of a dream with a white paw coming into my neck and placing a tiny little stick in it. And when I woke up that morning, I was very shocked to find a strange, painful lump on my neck. And when I felt it because I thought it was a pimple, I discovered something hard in there, the shape of a piece of rice. According to Molly, the tiny implant worked its way deep into her body, and before she could get medical advice, it disappeared without a trace. Another encounter that she vividly remembers actually involved being taken on board an alien spacecraft. I recall being in, I'm going to call it a clamshell, but it was more like a scallop, and it had a top and a bottom, and I can recall being inside of it and the top closed over you. I experienced medical procedures with very strange types of devices. One of the beings was very tall and very thin and very insect-like. Like most people who claim to have met aliens, Molly has no evidence at all to back up her story, and skeptics consider that experiences like hers are more to do with popular culture than extraterrestrials. Most people just give the default explanation that comes to mind, which is whatever they've been seeing on television and reading in popular magazines and books. Over hundreds of years, the phenomenon of visitations has manifested itself in a variety of guises. In the Middle Ages, people reported stories of angels and demons, while 100 years ago reports spoke of spirits and ghosts. Many scientists, including Shermer, believe that a combination of sci-fi stories, movies, and real-life exploration of space encourages people to manifest their fears in the form of alien visitations. The aliens are our angels, they are our demons. That's who we personify as these weird anomalies. We call them aliens because that's what we're into. We're in the space age, in the age of science fiction. However, that does not completely explain what causes people to believe they have experienced a visitation. Dr. Michael Persinger from Laurentian University in Canada believes he has discovered a link between the alien visitation sensation and electromagnetic fields. He suggests that fluctuations in electromagnetic activity could stimulate a reaction in the brains of certain individuals and account for most alien visitation experiences. The experience of a presence occurring, usually late at night, and either producing a mystical experience or a sexual experience, or even a terrifying experience, shows up in all cultures. And we now realize that this sensed presence is built into the human brain itself. Persinger believes that it is possible to induce something like an alien visitation experience in almost anyone. He does this by creating a complex electromagnetic field in his laboratory and applying it to people's brains. To demonstrate, Persinger and his assistant place a volunteer inside a soundproof chamber. Electrodes producing the magnetic field are attached to the subject's head. Then he is blindfolded and the lights are dimmed. Persinger monitors his stats and waits for his subject to experience a feeling similar to that of an alien presence. Within minutes, the electromagnetic fields trigger a shocking reaction in the subject's brain. How he describes it, it's going to be a function of his culture, his experiences and his expectations. I feel like a demon at this point. Persinger stops the experiment. In this study, the subject is visualizing the presence in a terrifying way. I've never had any feeling that ever, it just made me feel a little trapped, and it hurt. I don't know, closest I've ever been to hell. It was just an awful place to be. The volunteer was extremely sensitive to the electromagnetic fields, which stimulated his brain. However, this technique demonstrates the extraordinary power of our brain to turn our fears into monsters and demons, and even aliens from distant worlds. Dozens of people who have had experiences that they attributed to alien abductions and experiences, when we put them in the chamber, they have a very similar experience. The terrifying experiences induced in the chamber are caused by channeled electromagnetic fields. Persinger believes that abduction experiences in the real world are caused by electromagnetic fields created by natural phenomena such as sun flares, seismic activity, and changes in atmospheric conditions. And it's thought that our common physiology and global culture is responsible for the similarity in the accounts. Inevitably, we're all going to have similar experiences because our brains are wired that way. We'll see the same kinds of illusions, we'll have the same kinds of hallucinations, and so on. The role of electromagnetism in alien experiences is far from proven. Some researchers suggest that sleep paralysis or conditions like post-traumatic stress are to blame. But until we've made contact with ET, we may never know if aliens are all in the mind or not. And if ET did reveal itself, there could be another barrier to overcome: language. It may be that aliens don't choose to talk with us at all. They may decide to talk to one of the other species that inhabits the Earth, and that could be whichever species they consider possesses the most intelligent language. It may be possible for aliens to cross the interstellar void to land on Earth, and to adjust for survival in our atmosphere. But communicating with us in any meaningful way may prove to be the hardest step of all. We are arrogant to believe that they're going to want to actually talk to us and visit us. I mean, why? Think of ants in an anthill. If someone is building a 5-lane superhighway right next to the anthill, would the ants know how to communicate with the workers? The main danger is that these workers will simply pave over the anthill and not even realize what they've done. In San Francisco, a few scientists are already studying ways of communicating should ET ever come to call. Leading the hunt is SETI, the Search for Extraterrestrial Intelligence. For the last 40 years, SETI scientists have been monitoring the skies, listening for messages from alien species. SETI is just about every field you can imagine applied to the search for life in the universe. SETI scientist Lawrence Doyle believes that the key to communicating with aliens is first to understand their level of intelligence, and for that he needs to establish how organisms communicate. There hasn't been a search for extraterrestrial intelligence yet. There's only been a search for extraterrestrial technology. We plan to make it a search for intelligence by understanding the laws that create communication, so that if we get signals, we can tell it's a communication as opposed to random astrophysical processes. By understanding the laws that dictate communication, Doyle can identify and separate real patterns of communication from random noise. To do this, he uses a mathematical equation known as information theory, which was originally developed to quantify the amount of information sent down telephone lines. Doyle uses it to analyze the complexity of a language. He calculates the interdependency of different words or sounds within the language. The greater the number of words or sounds that can be strung together that are dependent on the first word or sound in the sequence, the more complex the language. On this scale, English is a level 9 communication system. Doyle now plans to use the same technique on alien communication, and the higher the complexity, the more superior the intelligence. Any alien or extraterrestrial message has to obey the rules of information theory. There's no other way to transmit information, and if we can measure how complex their communication is, it may be an indicator of how complex an extraterrestrial society is. But information theory can only help Doyle understand the complexity of an alien's signal, not the content. So even if he spots ET, he won't know what ET is saying. It's the same problem we have on Earth when humans try and communicate to other species. If you smile at a wolf, it does not mean I'm happy. It means you want to pick a fight. If you smile at a chimpanzee, it means you're scared. So even a smile doesn't work. How do you communicate with an alien is a tricky point. We can't even agree on the same symbols of greeting among species on Earth. Doyle has been using information theory to discern patterns and rules in animal communication and study their complexity. The results have been surprising. With his current data, Doyle has found that squirrel monkeys have a level 3 communication system, while dolphins have a level 4. So who does Doyle think might be the best candidates to communicate with aliens? So far, he's not convinced that either dolphins or humans have the necessary linguistic skills, but he has found a species on Earth with a communication level much higher, humpback whales. We're majoring on them because they look like they have the absolutely most complex communication system maybe on the planet. But despite listening to the universe for 4 decades, SETI has yet to discover a single confirmed extraterrestrial signal. To actually find real aliens, we may need to look in a different place, a place closer to home. Perhaps we should take a closer look at ourselves. When you look in the mirror, perhaps you are looking at a Martian. It's always amusing to me when I hear people talking about UFOs and aliens. But for me, it's the bacteria. There could be bacteria here that are really alien. Life on Earth could have come from Mars, and we could all be aliens here. McKay and other scientists believe there's a chance that billions of years ago, alien bacteria were blasted from the surface of another planet and carried away in a meteorite. The meteorite might have eventually crash-landed on Earth, spilling out the bacteria, allowing it to grow and flourish. It's a process called panspermia. If panspermia is true, you and I are aliens in the sense that our life did not develop on the planet that we're living now. Professor Jay Melosh of the University of Arizona has studied meteorites that have landed on Earth to see if they could have transported life from other worlds. This meteorite is a piece of Martian basalt. Where it came from was a large meteorite impact on the surface of Mars. It's almost an ideal delivery mechanism. It's ideal because the rock protects the bacteria from radiation and extreme temperatures in space. It would also protect it from the impact of crash landing on Earth. To test whether bacteria could travel safely through the cosmos, Melosh and his colleague Wayne Nicholson conduct an extreme survival experiment. They inject a large block of rock with bacteria and take the sample to the Ames Vertical Gun Laboratory near San Francisco. The block's placed inside a large vacuum chamber, ready, and then they fire a projectile into it at over 13,000 palo. It absolutely destroyed the rock target, blasted into tiny fragments. Amazingly, despite the rock being virtually vaporized, the bacteria survive intact. If they could survive, it's not a big stretch to think that organisms on the surface of another planet could also survive meteorite impact and launch into interplanetary space. The experiment shows that bacteria could not only survive the vacuum of space, but also the impact of landing on Earth. One theory is that bacteria from another world evolved over millions of years to form life as we know it. So perhaps all life on our planet is alien in origin. We, human beings, life, plants, animals, everything we see, descended from that common Martian ancestor. That's a possibility. We may go to Mars and suddenly see, well, that's where great-great-great-grandma lived. Because of the vast size of our galaxy, aliens, even highly advanced ones, may never have visited Earth in spaceships. All UFO sightings may well be no more than a simple misinterpretation of what we are seeing, and alien visitations a product of our overactive imaginations. But aliens might have been here all along. We, and all the species on our world, could be the direct descendants of extraterrestrial life forms. In the strangest twist of all, perhaps we are the aliens. The Earth, a giant mass of rock and water flying through space. It's unlike any other planet we know because it supports life. It's not just our home, it's the only safe haven we have in the universe. But how did it get here? What strange forces of nature created this living, breathing planet we depend on? It's a mystery scientists are only now beginning to solve. Naked Science brings together the latest research to discover just what it took to create an Earth on which people could live. In this vast cosmos, there is only one place we know where humans can survive. It seems as if the Earth was made for us. It supplies us with water to drink, food to eat, and air to breathe. It's the only home we have, and we rely on it entirely. But 5 billion years ago, it did not exist. Where the Earth now sits in the outer reaches of the Milky Way galaxy, there was just a large cloud of gas and dust. This is the astonishing story of what transformed that cloud of dust into the planet we know today. One person who understands what it takes to build a planet is astronomer Tom Fleming. Using telescopes like these at Kitt Peak in southern Arizona, astronomers have pieced together how the Earth was born. It all begins with a big cloud of gas and dust, little particles of dirty stuff, grains of sand, grains of silicon. Scientists call all these regions of dust and gas molecular clouds, but they're not like any clouds we see on Earth. Molecular clouds are vast. They cover hundreds of light years in size. It was from clouds like these, photographed by the Hubble Space Telescope, that the Earth formed. The clouds are made up from the debris of hundreds of dead stars. When stars from the early years of the universe burned up their fuel, they exploded and showered the surrounding space with their ashes. When the first generation of stars died, either gently or explosively, in an event we call a supernova, the heavier elements, the ions, the silicons, aluminum, nickel, that was created in the star is blown out back into the galaxy. This cocktail of elements creates a molecular cloud. From this, new stars are born, and planets. The force that drives their creation is gravity. The same force that attracts apples to Earth will attract two objects in space toward each other. It drew the dust particles of the molecular cloud together. Over the next 10 million years, the molecular cloud slowly contracts under the force of its own gravity. As our gas cloud collapses under the force of gravity to become a star, something very interesting happens. And I'm going to try and demonstrate what happens with these two lead balls in this carousel. Now I'll step up here on top of the carousel cell. I've now increased my mass by the mass of two lead balls, and I'm holding them straight out. So now the mass in my body is distributed at a distance far from the centre. Fleming is impersonating a molecular cloud. The weights represent its mass, which to start with is spread over a huge area. Now I'm going to ask Lucy to give me a hand here and give me a little bit of angular momentum. As I start spinning, I'm going to move the balls closer to the centre of my mass, and notice how faster I'm spinning, and when I bring them out, I slow down again. And as you can see, this is exactly what happens to the interstellar cloud. The large molecular cloud had a small rotation. When it shrank, this rotation speeded up. As the cloud contracted, the energy of the material flying in from space caused its centre to heat up. This spinning ball became our sun. The rest of the cloud was spinning so fast that it spread out into a vast disk of dust and gas. This was the cradle of life, the material that would form the Earth and all the other planets. Until recently, what turned this dust into a planet was a mystery. Then, In March 2003, a light-hearted experiment on board the International Space Station led to a significant discovery. Astronaut Don Pettit was curious to see the effects of weightlessness on different substances. In a series of simple experiments, he filmed bubbles, indigestion tablets, swirls of coloured water, then filled the plastic bag with salt. This last experiment turned out to be a scientific revelation, but at the time Pettit didn't realise its significance. The person who worked out what it meant was fellow astronaut Stanley Love. Don likes to mess with things, and one of the things he messed with was putting things in plastic bags, granular solids like sugar, salt, instant coffee. He put them in a bag, inflated the bag, and shook them up just to see what would happen. And what happened was, the little particles formed up into clumps like dust bunnies instantly. When he saw a video of the experiment, Love realised that he was witnessing a significant discovery. And Don shot this video down. He said, "This is cool, isn't this neat?" and showed all his little videos and his different substances and the different bags. And I said, "Don, yeah, that is neat. Actually, you've solved a very old problem in planet formation." In zero gravity, the crystals behaved completely differently to the way they behave on Earth. Love recognised what was making them stick together. Well, anytime two different materials rub together, you can have a few electrons get traded off from one material to another. This happens when you rub a rubber balloon on your hair and stick it to the wall. As it turns out, once you get dust or basically anything in zero gravity and shake it up, let it bump into each other, we think it gets some sort of electrostatic charge on it, which makes it clump up together just immediately. You can break up the clumps by shaking the bag up, and then they reform as soon as you stop shaking it. In the first few seconds of its life, our Earth may have looked something like this. Scientists think that this moment occurred 4.52 billion years ago. To follow the evolution of our planet, naked science is going to represent the time from then to the present as 12 hours on the face of a clock. At noon, the clock started ticking. The Earth's journey toward becoming a planet that can support life has begun. The first step didn't take long. Once clumps of these particles had grown into objects about half a mile in diameter, their mass was great enough for their gravitational pull to attract material from the surrounding disk. Like giant vacuum cleaners, they circled the sun, sucking in material from the disk until there was nothing left to consume. In the inner solar system, these clumps grew into around 20 planets. This process took about 3 million years, less than 30 seconds on our clock. The next stage of the Earth's evolution was incredibly violent. As these 20 planets orbited the sun, their gravity affected each other, and they began to collide. With each collision, two planets combined. Over time, these collisions reduced the inner solar system to just a few planets, including Venus, Mercury, Mars, and Earth. Astronomers believe that the Earth grew to this stage in around 30 million years. We are now just 5 minutes into our story. But what was early Earth like? What would happen if a human had landed here? The energy from the collisions with other planets made the Earth incredibly hot. At around 8,200, its temperature is more than 5 times that inside a cremation furnace. A human would almost instantly disappear in a puff of steam and ash. But even as our planet cools down, another danger threatens. A storm of charged particles is approaching the young Earth. It's so intense that it could end all chance of life. 4.5 billion years ago, a giant cloud of dust collapsed to form our solar system. The Sun, planets and Earth. But as the newly formed Earth began to cool, it faced one of the biggest threats to its existence, a hurricane of deadly particles from the Sun. Boulder, Colorado, at the Space Environment Center, meteorologists monitor the storms on the Sun. It's the most extreme weather you're likely to see. A light breeze out there is 200 miles per second, and a low temperature is 8,000 VF. Around-the-clock surveillance is necessary because storms on the Sun affect us here on Earth. Space scientist Rodney Virek knows just how deadly the Sun can be. The Sun is a large explosion, and from that explosion, energetic particles are released. These particles make up the solar wind, and they travel toward Earth at speeds of up to 1 million miles an hour. If the solar wind becomes too strong, it can kill. We watch the Sun, And when we see something that may produce energetic particle events here at Earth, we try and warn astronauts, even airlines, about these types of events. The charged particles in the solar wind are a form of radiation that can cause lethal damage to living cells. An intense solar storm could kill an astronaut caught in space. But the solar wind can also have a devastating effect on planets. The Earth is surrounded by an atmosphere, a thin layer of gases that protects it from the extreme temperatures of outer space. But when the charged particles in the solar wind hit a planet's atmosphere, they can strip it away. You can see how destructive the wind can be by looking at Mars. Over millions of years, the solar wind has blown away most of its atmosphere. Now there is no liquid water on the surface, too little air to breathe. This could have been the fate of the Earth, so why wasn't it? The answer lies in the moment of the Earth's creation. As the early Earth was forming, the energy released as material hit the planet produced heat. The heat became so intense that even rock melted. The lightest elements in the molten Earth rose to the surface, while the heaviest elements, including iron, sank down toward the center. Here they formed a molten core. It's this iron core that protects us from the deadly effects of the sun's rays. Exactly how the Earth's core protects us is a mystery that drives the research of Dan Lathrop. In his laboratory at the University of Maryland, he spins scale models of the core to study how it behaves. The Earth's core has dynamo action that makes a magnetic field, and that's a process where currents in the liquid iron cause magnetic fields. Lathrop has found that the spinning motion of the core creates a magnetic shield that surrounds the Earth. You can see it's mostly axisymmetric, but you're getting small details that are rotating around with the inner sphere. To show how it does this, Lathrop has rigged up a simple high school experiment. We can see how the currents produce magnetic fields with this simple demo. Just take some iron filings and sprinkle them down around this coil of wire. This coil of wire represents the core of the Earth. The iron filings will reveal the shape of any magnetic field, and then hook the coil up to a power supply. You can see the iron filings line up with the magnetic field lines, and the magnetic field lines are passing through the center of the coil, looping around the ends. The electricity in the coil produces a magnetic field. The same thing happens on a larger scale with the Earth's core. Its magnetic field gives our planet its north and south poles. It also extends far out into space. It's called the magnetosphere, and this is what protects us from the solar wind. As particles from the sun fly toward the Earth, the magnetosphere blocks their path. Those that get through are deflected toward the poles. Here, as they enter the Earth's atmosphere, they react with molecules in the air to create the aurora, the northern and southern lights. Today, the solar wind still erodes our atmosphere, but thanks to the magnetosphere, the loss is not life-threatening. It's been estimated that between 5 and 10 pounds a second of our atmosphere are dragged out into the solar wind. Fortunately for us, even at that rate, the amount of time it would take to deplete our atmosphere would be many times the life of the sun. The magnetic field produced by the iron in the center of the Earth played a vital role in our planet's evolution. Without it, we wouldn't have any air to breathe. On our clock, in which 12 hours represents the whole history of the Earth, just 6 minutes have passed. The Earth still doesn't look like the planet we know, but could a human now survive on its surface? It's possible that the Earth may have cooled enough for a human to survive in a heat-resistant suit, and thanks to its iron core, our planet is now protected from the solar wind. But there is still no oxygen or water on Earth. We wouldn't last a minute. Worse still, if a human could survive, they would be in for a shock. An astonishing event is about to take place. The Earth is on a collision course with another planet, and about to experience the biggest bang in its history. So far, we have seen how a giant cloud of gas and dust collapsed to form our solar system, and how the Earth's molten iron core created a magnetic field that protected the planet from the deadly effects of the solar wind. The Earth's formation was a violent and dramatic process, but an even more astonishing event was about to take place, a collision so large that it would melt the whole planet. And the only reason we know this event happened is thanks to a large object circling over our heads, the Moon. The Moon is the Earth's constant companion. For centuries, humans wondered where it came from. There were many theories. Some thought that it was formed by the early Earth spinning so fast that it threw off material into space. Others proposed that the Moon was a passing planet captured by the Earth's gravity, but no one really knew. In 1963, the United States launched the Apollo program. One of the mission's aims was to discover how the Moon was formed. In the late 1960s and early 70s, American astronauts made 6 visits to the Moon. They played golf, tested their skills at off-road driving, and collected 840 lbs of moon rock for scientists back home to study. The pieces they brought back to Earth revealed something strange. When scientists examined them, they found that they were very dry, as if they had been heated. This was baffling. Any theory of the Moon's creation needed to explain this mystery. In the 1990s, planetary scientist Robin Canup decided to put a new theory to the test using a supercomputer simulation. She modelled what would happen if the Earth collided with another planet. The results were a revelation. This is a simulation of a single impact by a roughly Mars-sized planet, shown here on the upper right, colliding with the young proto-Earth represented by this object here. So the impactor comes in and hits the Earth at a very oblique angle, at about 45, and you can see this long arm of material right here. That's actually the impactor. It's been stretched out and distorted by the impact event itself. There's an inner clump of material, you can see it right here, that will re-impact with the Earth after a little more time. This outer clump of impactor material, it makes a very close pass by the Earth as a result of the Earth's gravity. This initial clump is sheared out into a long arm of material, which then finally breaks up to form a disk. And it's from this disk of material orbiting the Earth that we believe the Moon then later accumulates. From this simulation, Canup has figured out exactly what happened during the impact. There would have been this unbelievably large impacting planet racing towards the Earth at a speed of 7 miles per second. This would have been an enormous object, a planet that was half the size of the Earth itself, and so would have completely filled the sky just before impact. The impact itself was an incredibly energetic event, with enough energy to completely melt the whole of the Earth and vaporize a significant portion of the rock in the Earth. When the planet hit the Earth, the glancing blow smashed material into space. Much of this debris stayed in orbit as a vast disk of rock and dust. A clump of this circling material then became large enough for its gravity to suck in other matter from the disk, and this became our Moon. It's now 50 million years since the Earth began to form. On our clock, in which 12 hours represents the whole of Earth history, still only 8 minutes have passed. At this stage in its life, the Earth appeared very different to the planet we know. The ground remained molten from the impact for thousands of years, and the Moon was 15 times closer than it is today. You can imagine what is now a stunning sight on a full moon night would have been breathtaking at that time, with the Moon 15 times larger than we currently see it. The collision with the planet and the formation of the Moon were key events in creating an Earth fit for life. The collision could have tilted the Earth on its axis. This tilt gives us the seasons. Thanks to this tilt, the Earth's climate changes gently through the year. It gives us the annual cycle of life. It may have been possible for life to evolve on Earth without these seasons, but it would have been a very different planet from the one we know today. The creation of the Moon also gave us the tides. When the Moon was close, these were much stronger, but they have weakened as the Moon has slowly drifted away. Nowadays we take the oceans for granted, but 4.2 billion years ago they didn't exist, and without water there could be no life. Where all our water came from and how it got here is one of the most amazing stories in science. Naked Science is investigating the birth of the Earth. How did nature build a planet on which humans could live? So far we've seen that the Earth formed from a giant cloud of gas and dust. Its iron core created a magnetic field that protected it from the deadly particles of the solar wind, and it survived a big hit from another planet. But for the Earth to have life, it had to have water. Where that came from is one of the great mysteries of science. There are currently around 326 million trillion gallons of water on the planet. That's 394 trillion Olympic swimming pools. But many astronomers think that, if the early Earth contained water at all, it had very little. At the time the Earth was forming, the inner solar system was too hot for liquid water to exist. The region from the Sun to the asteroid belt was almost bone dry. The nearest water reserves to the Earth were now 160 million miles away in the outer asteroid belt. Out here, far from the Sun's heat, water froze and was incorporated into the forming planets and other objects. But how the water could have travelled from here to the Earth is a mystery scientists are only just beginning to solve. One clue came with the blastoff in January 2005 of an unusual NASA spacecraft named Deep Impact. Its mission was to fly 270 million miles to a comet named Tempel 1 and launch an 800 Lelpy copper impactor into its surface. The mission was the latest attempt to understand some of the most mysterious objects in our solar system. For centuries, people had argued that comets had brought water to Earth. When they looked at the Moon, it was clear from the craters that its surface had been bombarded by large objects. Similar objects must also have hit the Earth, although our planet's much more dynamic geological activity has since erased all trace of them. Scientists also felt certain that comets contained water in the form of ice, but the Deep Impact mission was the first time anyone had probed inside one. On the morning of July 4, 2005, NASA scientists waited anxiously as the impactor approached the comet at a speed of 23,000. It scored a direct hit. The explosion was captured by telescopes around the world. Analysis of the debris confirmed that comets contain significant amounts of water, but could they have brought that water to Earth? Using radio telescopes, astronomers have studied the type of water in the vapor trails of comets. They wanted to know if it matched the water on Earth. So far, scientists have only analysed 3 comets, but the results are not encouraging for the comet theory. The water in all these comets was not the same as the water in our oceans. The comet theory isn't yet dead, but it's fizzling out of steam. In its place, scientists have evolved an exciting new idea. A vital clue arrived on January 18th, 2000. That evening, the sky above Western Canada lit up with a bright light. Dozens of witnesses saw a meteorite enter the Earth's atmosphere. Seconds after the event, local photographers took these pictures of the trail it left in the sky. As it fell to Earth, the meteor broke up into dozens of pieces and landed on Tagish Lake in British Columbia. Within days, scientists were on the scene, extracting the frozen remains. The pieces they pulled from the ice were the best preserved meteorites ever recovered, still intact. A piece was shipped to NASA's laboratories at the Johnson Space Center in Houston. Here, space scientist Michael Zolensky examined it. The meteorite was remarkably undamaged, despite heating up through friction as it entered the Earth's atmosphere. The meteorites, they're cold-soaked in space for millions of years, so they're very cold. And the air in the atmosphere at high velocity, and they do in fact get very hot on the outside, but they're only heated for a few seconds, and it's not long enough for the heat to get all the way in past a few millimeters actually. This means that when meteorites hit the ground, they cool very quickly. You hear of reports of meteorites causing fires on the ground, things like that. That's always wrong. They're actually quite cold to the touch after a few seconds. But when a meteorite is fragile like the one at Tagish Lake, where it lands makes all the difference. Very lucky it fell in a frozen lake. If it had fallen anywhere else, it would have easily fallen apart to dust in a few days. And so it's quite possible this kind of meteorite falls to Earth very, very commonly. It's just usually destroyed, because the inside of the meteorite remained frozen. Zelensky was able to analyze what it was made of. This is a sample of Tagish Lake meteorite. The black material here is mostly clay minerals, the kind you'd find in your yard, and these clay minerals contain water molecules trapped inside. And so about 20% of this meteorite by weight is water. That's a huge amount. From the location and angle at which the meteorite fell, astronomers traced its orbit back into space. They discovered that it came from the outer reaches of the asteroid belt. If you do telescopic observations of asteroids, what you find is, as you move farther and farther from the Sun, the asteroids have more and more water. Now astronomers suspect that asteroids from this outer part of the belt brought water to Earth. If they're right, our oceans came from space in a torrential shower of meteorites. But one question remains: What could have caused so many asteroids to swing out of their orbit and come crashing to Earth? The culprit appears to be the biggest planet in the solar system, Jupiter. Jupiter lies just beyond the asteroid belt, and its mass is so great that its gravity disrupts the path of any object it comes near. In the distant past, it pulled thousands of asteroids out of their normal circular orbits into elliptical orbits that cross the path of the Earth. When that happened, collisions were inevitable. The Earth was bombarded. As the asteroids crashed to Earth, they smashed apart. Water inside them escaped. Explosion by explosion, they created the oceans we see today. Scientists used to think it took hundreds of millions of years for the Earth to acquire its water. But recent evidence suggests it arrived remarkably quickly. The evidence comes from research carried out by geologist Stephen Mogesis in his laboratory in Boulder, Colorado. Mogesis took some of the oldest rocks in the world and ground them down. From inside them, he extracted tiny crystals called zircon. A zircon is a common mineral. It's generally small, it's hard to destroy. Using an ion microprobe, Mogesis then analyzed the zircons and measured the composition of the oxygen inside them. He found that the crystals had formed from a particular type of rock, one that could only have existed if there was water on Earth. What was startling, exciting, fun was that these zircons showed not only that things on the Earth's surface had stabilized to within normal conditions, but that water was present, and water was present everywhere. Mogesis estimated the time the Earth acquired its water from the age of the zircons. The zircons in some of the rocks there are very close to 4.4 billion years old. This evidence suggests that the Earth's water arrived in less than 150 million years. On our clock, on which 12 hours represents the whole history of the Earth, that's just 25 minutes after the planet began to form. At this time, our Earth would certainly have looked very different. The sea was full of iron, much of it brought up from below by hydrothermal vents, and the atmosphere was a lot thicker than it is today. An ocean rich in iron would have appeared green. A denser atmosphere would have given a reddish tinge to the sky. Conditions for human existence are looking better. The land has now cooled to a tolerable temperature, and there is water to sustain life. But there is still one horrendous problem. The gases in the atmosphere are mainly nitrogen, carbon dioxide and methane. There's not a lungful of oxygen in sight. Without oxygen to breathe, there's no way a human could survive. In the early years of its life, the Earth experienced a violent and tempestuous onslaught. In time, the activity slowed until 500 million years after it began to form. The Earth had cooled and was covered in oceans, but there was still no oxygen in the atmosphere. Without that, animals and humans could not exist. One scientist who has investigated how the Earth acquired its oxygen is geologist Martin van Kranendonk. His research has brought him to Shark Bay on the west coast of Australia. It's a World Heritage Site, home to vast meadows of seagrass, dugongs and tame dolphins. But van Kranendonk has come to visit much older living things. This is one of only 2 places in the world where these strange living structures called stromatolites are known to exist. These stromatolites have been growing here since the end of the last ice age, about 10,000 years ago, and at that time the sea level was a little bit higher, and so these structures grew up to the present height that you see them. Stromatolites are primitive structures. Here they come in 2 forms: short pillars of living bacteria and silt, and flat bacterial mats. The living part of the stromatolite is made up of blue-green bacteria that grow using photosynthesis. They take energy from the sun and convert carbon dioxide into oxygen. It's really the result of this process of giving off oxygen that we have planet Earth as we know it today, and habitats that people like us, humans, and all the other animals and plants are able to live on planet Earth. What makes van Kranendonk believe that stromatolites created the Earth's oxygen is a remarkable discovery 1,000 miles away in a remote region of North Australia. This is the Pilbara, one of the oldest landscapes in the world. If you want to find out what happened early in the Earth's history, this is the place to come. It was really like you're transported back into a time machine of early Earth. That just sort of gave me goosebumps and shivers to walk over this ancient environment where you could still see the processes that happened 3.2 billion years ago. Here, at a location kept secret to preserve them, lie the oldest fossils ever discovered, the ancestors of the stromatolites in Shark Bay. What's remarkable about this outcrop in the Pilbara is that it contains the oldest evidence for life on Earth. We're looking at here in front of me our great-great-great-great-great-grandfathers and grandmothers. No one knows how life on Earth began, but these amazing fossils suggest that it emerged very soon after the planet formed. These fossil stromatolites are 15 times older than the dinosaurs. The bacteria that made them were living here just 1 billion years after the birth of the Earth. On our 12-hour clock, the time is now 20 minutes to 3. These would have been the first organisms that would have started the process of change of Earth's atmosphere to an oxygen-rich atmosphere, which has allowed us, mankind, and all the rest of life that we know today, to evolve on planet Earth. If stromatolites existed on the Earth 3.5 billion years ago, they should have started to increase the amount of oxygen in the air, but it appears that they didn't. For the next billion years, the oxygen level in the atmosphere hardly changed. What happened to all the oxygen the stromatolites produced? The answer can be seen 300 metres away in this gorge in Australia's Karijini National Park. Hidden in these rocks lies the key to the mystery of the missing oxygen. Geologists call these rocks banded iron formations, and they believe that they owe their existence to stromatolites. While these banded iron formations are the product of a remarkable set of circumstances in Earth history, they formed about 2.5 billion years ago when the Earth was very young, and are the product, we think now, of microbial action in the ancient oceans. The Earth's early oceans were full of iron. As the bacteria in stromatolites bubbled out oxygen, it reacted with the iron in the water. You can see what happened in this simple experiment. This flask of water contains iron. It's the same colour as the early oceans on Earth. This pump does the work of a stromatolite, pumping out oxygen. As the oxygen bubbles through the water, it reacts with the iron to form iron oxide, and it precipitates out as rust. There was so much iron in the oceans that for over 1 billion years it absorbed nearly all the oxygen that the stromatolites produced. As the rust precipitated out, it fell to the bottom of the ocean and was turned into rock. It has been estimated that around the world, these rocks have locked inside them more than 20 times the amount of oxygen that is in the atmosphere today, and they took an incredibly long time to form. On our clock, in which the whole history of the Earth is represented as 12 hours, we can see that the planet forms in the first 8 minutes. After 25 minutes, it has cooled and collected water on its surface. But it takes another 4.5 hours to remove most of the iron from the oceans and deposit it in these rocks. Only then does the oxygen level in the atmosphere start to increase. This happened approximately 2.2 billion years ago, and for the next 2 billion years, the level rose until, just 500 million years ago, it reached the level at which animals could survive. So is our planet finally fit for human life. By this time, it has certainly cooled. There is water to drink and air to breathe. If we could travel back to this time, we could certainly survive. In our story, 11 hours have now passed, but the Earth still has a long way to go before the first humans will walk on its surface. At 37 minutes to midnight, dinosaurs will emerge. At 10 minutes to midnight, they will be wiped out by a catastrophe. Finally, at 19 seconds to midnight, the first humans will appear. It has taken over 4 billion years, but out of a vast region of freezing dust and gas, the forces of nature have created the only safe haven we have in the universe, our home, the Earth.